Okay, namaste and good morning to everybody. Today we will talk about vectors, but vectors we do not deal in physics just for sake of vectors. It's not a mathematical treatment. Vectors we will teach or learn so far as relation to use in physics is concerned. So vectors we are not studying for the sake of vectors. Vectors we are studying are for the sake of its use in physics. It's used in learning physics. It's used in communicating physics. Okay. So as you know, there are two types of quantities. Rather, there may be many types of quantities. One is that where you can characterize by only magnitude, like mass of this duster. You need only one number, that is the say kilogram or gram. So only one number is required to characterize the mass or specify the mass of this duster. But suppose this starts moving, then only mass will not be sufficient. Then we have to give the direction also, in which direction it is moving. So vectors will have two properties or two specific entities like mass, number and direction. So vectors are quantities which have magnitude and direction. All right, fine. Now when we go to directions, there are certain conventions that we should remember. One is northeast. So this is east, this is the west, all right, this is the north, this is south. There are some other, this is a convention, everybody understand that this is the east, this is the west, this is north, this is east. As I said, when you want to communicate physics, you have to agree to some basic rules. So this is one of the rules that we follow all over the world, internationally accepted. This is the east, this is the west, this is north, this is south. Okay, fine. Now this angle is 90 degree already, you know it. So okay, any point in between like this one. So this is known as northeast, this is known as northwest, this is known as, this is known as, all right, fine. In between, that means 45 degree. Anything that makes a 40 point, that makes 45 degree angle to each of, you can call it east, north or northeast, all right, the same thing. Is that okay? Now suppose there is point over here, or there is a vector this direction, this makes angle 30 or 30 degrees, say, let us know. So how to describe this one? We can describe as 30 degree north of east. Let me write it. So it should be very clear in the very beginning in this lecture. 30 degree north okay. North of east means you are moving from east. North of east means you are moving from east. And how much? 30 degree. I can also say the same thing as 60 degree east of north. Is that okay? So this is the convention that we will follow. All right. Then measuring angle, there is a convention that when we go in this anti-clockwise, they are positive. When we go this way, then it is a positive. You go the other way, it is negative. Fine. So this is okay. Fine. So as I said, vectors have direction and they have magnitude. So how do we represent vectors? We represent by a line, arrow. So there is also a convention. We put a dot here and arrow at the tip, at the head. Okay, not anywhere in between. For a current element, you can put arrow anywhere you want. But for vector, you have to put it on the head only. So this is a vector A, and say there is a vector B. So there are two vectors. Whether they are equal or not, how it will be decided? By two characteristics. One is the length of the vector. Length of the vector line will give me the magnitude and the direction. So these two are not equal, you can see it. Magnitude is not equal, direction is not equal. So now if two are equal, two vectors are equal, then we write it like this. So that means they are in the same direction. So suppose I want to put a draw a vector parallel to this, equal to this, then I will put a like this, equal in magnitude and in the same direction. Fine. If you want to say a vector which is minus a, opposite direction. So they are basic, we are just visiting. So this is opposite direction. All right. So there are certain rules about vector additions. The rules are that you suppose I want to add a and b. What I will do? Add a to b. So what I will do? From this point I can draw a parallel to this vector. Fine. Okay. And then you can use a triangle law or you can use a parallelogram law. So you draw a line parallel to this and equal in magnitude. All right. Draw a line parallel to this equal in magnitude. So this is like this. And then join the origin, this point, to the point where they cross. So this will give me the result. Fine. So now there is a certain formula here there. If this angle is theta and this angle is alpha, so there is a cosine law. So that law is known as tan alpha. We can derive it, there is no problem. Tan alpha is equal to, say this is b, b is sine theta, sorry, v sine theta divided by, you add this a plus b cos theta. Okay, so there is no need to derive it. You can derive it very easily. You simply drop a perpendicular from here, and so this becomes cosine one, this becomes sine. So you can simply draw it. All right, we will not do that. So there is another rule. This is known as sine rule. This is a triangular sine rule. Is just a general rule for any situation. Okay, so let us say this side is A, this side is B, this side is C. Okay, the triangle rule says that it relates the sides with the angles facing that side. The sine rules relate the angle facing the particular side. Like this, we can write at sine C divided by this angle. The facing side is this, so let me write it as AB is equal to sine of A or sine of B with the facing angle is side is AC. Okay, is equal to sine A upon BC. A is okay. Yes, A is BC. Okay, fine, fine. So this is sine law and this is cosine law. Okay, fine. Now there are some more definitions. One is when we define a vector, we also define a unit vectors. A unit vector, suppose there is a vector A here. This is a vector A. So a unit vector in this direction, let us say, you can put it like anyway. You put a, first there is a convention, we put a cap, or some people call it hat, anything you like. This is a unit vector in this direction. This is defined like this, the vector A divided by its magnitude. Is that okay? All right. Now conventionally we have designed three unit vectors. We work with three unit vectors. They are known as I, J and K along three axes, three Cartesian axes. Okay. So say let us say So this is I. Again we put a cap over here. This is J and this is K. They are known as orthogonal right-handed, orthogonal right-handed coordinate system. Why right-handed? Because this K could be any way. How do you visualize this IJK? Which are the directions? So suppose there is a vector. First thing, the angle between the three are mutually 90 degree. Okay. So let us say there is a vector V is equal to some number I plus Vj plus Ck. So where is this vector? How to draw this vector? Can you visualize this vector? Where is this vector? Okay, I will show you. Let us put it over here. All right. Can you see this? Where is my A? I. So let us say I take this I. I vector is in this direction. J vector is in this direction. Okay. So IJ plane is this plane. Okay. K, now K can be this or K could be down also. K could, they are perpendicular. Now what is the angle between I and J? This and this, 90 degree. What is the angle between this and K and I? You can see it is 90 degree. What is the angle between K and J? It is 90 degree. Fine. Minus K is down this. So K could be this way or K could be down. So we have to follow some convention. The down one is also perpendicular to I and J. So it satisfies the rule that they should be perpendicular. So that is why we have devised this rule, right-handed rule. In the right-handed, okay, just so let us see a vector. First, let us see a vector which is V is equal to AI Vj plus Ck. Where is that vector? Just visualize in this system. So AI is this, Vj is this. So where AI, if you add this AI with Vj, the vector is in this direction. Is that okay? My AI is this, Vj is this. If I add these two vectors, draw a parallel over here. This is the AI plus Vj in xy plane. Fine. And then you add this one. So how do I use the vector formula, addition formula? I have to transport this vector parallel to this surface. So I bring it over here. Okay. And then add this. So this one plus this one, where you go? This vector. So this point connecting this point is my V vector. Okay. Is that clear? Fine. So why we said right-handed system, we have to adopt some convention. And what the convention is that if you put a right-handed screw and rotate it from I to J, then the screw will move in this direction, upward. If you do the other way, it will move downward. Okay. So we have adopted the right-handed convention. Now there is another confusion that is should be clear right now, so that in future you don't face this. I can rotate this axis by 90 degree. I can rotate this axis by 90 degree without changing anything. But in which direction? In anti-clockwise direction. So let us say the same axis is this also. I rotate by 90 degree. So this becomes I. I rotate by 90 degree. So this becomes I. Where J goes? J goes here. And where K goes? So they are equivalent. Remember this. I can draw the same coordinate system as this also. So what I have done? I have simply rotated the whole thing by 90 degree. So I has taken the position of J, J has taken the position of K, K has taken the position of I. Can I do another rotation? So you write in some textbook you find that they are writing IJK like this. Some textbook they are writing as this IJK like this. Both are equivalent. Is it clear now? So can you give another rotation by 90 degree? Rotate by 90 degree again, this one. So what happens? This becomes I. Is that okay? Where J goes at this place. Okay. And where K goes? K goes. All right. This we can also take this one, but usually we do not take this one because by convention we are taking this as a positive direction. So J is this positive direction. Here the positive directions are not being disturbed. Here you find that J is going in this direction. So this is not the positive direction we are defining. We have to be consistent with the origin also and coordinate system, like X is positive in this direction, Y is positive in this direction, and Z is positive in this direction. So we are these two are consistent with this notation. That is why we follow these two. So now it is clear what is why it is 90 degree and how much is that. So vectors we have unit vectors and we can express in terms of x, y, and j. So let us say a vector is like this. Say some component ax, ay plus, fine. Ax, ay, and az are components, simply components, fine. So how do you describe this? Let us take a system. So suppose the vector is here over here. So you draw a perpendicular, ij perpendicular. So this is my ax. Up to this is ax. You draw a perpendicular, this is ay, and you draw a perpendicular over this one and join this, then you get az. Is that okay? So let us have some problems. Can we? Okay. Question number one. Just try to solve this question or your notebooks. Question number 1. State which are the following are vectors. Just write your answers on your notebook. Weight, specific heat, density, volume, speed. Any vector you encounter? Calorie, momentum, energy, distance, magnetic field, electric field. Which are vectors? Momentum is a vector. And what about other? Magnetic field is a vector. Then next is electric field is also a vector. Any other vectors which we have left? Any other vectors? Any other quantity which are vectors? Again read carefully. Specific heat is not a vector. Density is not a vector. Volume is not a vector. Speed is not a vector. Calorie is not a vector. Momentum is a vector. Energy is not a vector. Distance is not a vector. But displacement is a vector. Okay. The magnetic field intensity is a vector. Electric field is a vector. What about the first one? Weight. Is it a vector or not? Does it have a direction? Which direction? What does this downward mean? Downward means there is a force of attraction towards our center of Earth. Okay, so suppose my Earth is like this. You are here, so your weight is towards this, right? Suppose this Earth is spherical, almost spherical. You are somewhere here. So where is the downward direction? Towards. So which is this? Somebody is over here. This is the downward direction. Somebody over here. This is the downward direction. Somebody here. This is the downward direction. So downward word is a confusing word. It's a relative word. It depends on where you are standing, where you are. So towards the center is the proper word in physics. Towards the center of the earth is the proper word in physics, not the downward or upward. Downward or upward does not mean anything. It's not a specific thing. You have to say towards the center of the earth, then there is no confusion. Somebody over here, for him towards the center is this direction only. For somebody here, towards the center is this direction. Okay, fine. So we have to be, as I told you, there is no scope of using words loosely in physics. You cannot play with words in physics. You have to be very specific. You have to use concise and precise words. Okay, so this is what we mean. What about, so weight you have found, and how do we express it? Weight W is equal to mg. So I should write it like this. Is that okay? If you use the coordinate system like this one, then I can write it like this: m g. Should write like this: mg. You should be very clear about minus and plus sign in physics. Otherwise, you will land in trouble. When we go to mechanics, even magnetism, electricity, minus sign and plus sign is we have to keep track of. Otherwise, you are going to be in problem. So I have put it minus k. Once I have defined, say this is the not the axis we are using. We are using I here. So j here. So this is k here. So for this one, minus k is this. Is that okay? So I can write mg is equal to mg, g of magnitude minus k. All right. So this is a preliminary vectors. So this is also a vector. Let us go to question number 2. Do question number 2. Addition of vectors. Just do it. You don't write questions, write solutions. Solve it. I have already defined you what northeast means, what north means. So draw the diagram in your notebook and find the result. Anybody who got it? So I have to give another formula to you. This is, there are two vectors A and B. The angle is theta. So the resultant is the R resultant vector magnitude is A square plus B square plus 2AB cosine theta. So you can use this, you can graphically solve this problem. You got it? Answer? All right. What is the answer? Let us do it. So as I have said, you have to define. So this is north. Cos 45 is the angle. What is the resultant displacement? Displacement. Resultant. What is the resultant? It says that it travels 3 kilometer. So to north. So this is the 3 kilometer, one vector, and then it travels 5 kilometer northeast. Where is northeast? This is east. As I said, northeast is the point over here in the center. So it travels over here. This is the another vector.
Root 34 plus 30 by root
Okay, so you can see it. This is my A vector and this is my V vector. So what is the resultant? This is the resultant. Okay, so you can find it, no problem. So go to the next third question, number third. Question number 3. Following displacement 10 meter northwest. First mark your direction north, east, west and south. Everybody is able to solve or not? First two questions, everybody is able to solve. Question number 3. Visualize, first draw the diagram on your note sheet and then do it. Northwest. So your north is this, south is this, east is this. So northwest, where is northwest? Is this one. Okay, so it goes northwest. So this is the one vector. Then it goes 20 meter 30 degree north of east. North of east. So north of east is something 30 degree. 30 degree north of this is east. So 30 degree is this one. Is that okay? So it goes from here, not from here. So that means this is a dotted one. So it is going from here. All right. Is that okay? So I can draw a diagram line over here. This is 30 degree. So this is our north 30 degree north of east. And then due 35 meter due south. South is this one. So that means you are going like this. This is your 10 meters. Then you are going like this, 20 meters. Then you are going like this. All right. You can use a graph, you can add it. It is in cyclic order. You are going this way, you are going this way. That means the resultant is where in this direction? Which is the resultant of first two? I am going this way. Then I am going this way. So where is the resultant? From this point to this point. Okay. And where is this one? This is in this direction. Okay, fine. All right. So what is the angle? You can find the resultant over here. What is the magnitude? This angle is 30 is this angle. And what is this angle? It is northwest. So northwest, this is 45. This 45. So this is actually 45 and this is 30. So this angle is 75. Is that okay? So you can find the resultant of these two. You can use the formula. Is that okay? Angle is okay? Is there any confusion? 75 degree, is that okay for everybody? 30 degree is this one and 45 degree is this one. This is we call it northwest. So 75 degree, you can find what is the resultant between 10 and 20. All right, you can work out, there is no problem. And then cosine of this angle, you need the cosine of this. How to find cosine of 75? Any formula? 90 45 plus 30. Cos A plus cos B. Cosine A plus cosine B. Okay. So 45 we know, 30 we know. So cosine A plus B. All right. So you can find and then add these two. Whatever magnitude is gets, simply add means they are in opposite directions, so simply and you have a calculator in your mobile. You take out your mobile. You don't have a calculator in your mobile? You have. Where is your mobile? You don't carry it? Fine. So let me take mine one. Have you checked what is 75? Do you get it? So it is 0.92. Are you getting 0.92? Are you getting it? Cosine A plus B, 30 plus 45. Are you getting 0.92? Yes, okay. So now you find what is the resultant of 10 and 20. So 20 square plus 10 square plus 2, 20 into 10 into cosine of, I've already given you the cosine value 0.92. Cosine 75 is 0.92. Root 868. Okay, fine. So that will be approximately how much? So 868, let us say, take some convenient point. You know, physics we also approximate. So you said 868. Let us take some convenient number. 840 or 900. Let us take 900. Let us take 900. You know what is 900? We take 900. What is the square root of 900? 30. So take it 30. So that is upper end. Okay, 30. And the other is direction is this only. The other vector is 35. So what is the value? 30 plus 35. No, not plus. One is the upper one. This is 30. This is 35. So that means your vector is, total vector is minus 5, about minus 5. In which direction? In which direction? It is, so not downward. Again, we are not using the word downward. Towards south. Towards south. Not downward. Towards south. Towards south. Okay. Resultant is towards south. Fine. So we go to the other one. Question number 4. Can we go to question number 4? Question number 4. First, try to visualize this question. So the moment you read first sentence, you should just draw a line, draw a vector. First, mark your north, south, east, west direction. Okay, and then an airplane moves in northwesterly direction. At one northwesterly means northwest. Okay, so that means 45 degree. Is that okay? So just try a vector in that direction. Due to a fact that there is a westerly wind of 50 km relative to the ground. So there is another vector in this direction, in west direction, and the value is 50 km. Okay. How fast and in what direction would the plane have traveled if there were no wind? So that means 125 is the resultant one because of the wind. Is that okay? So right, mark your directions. This is our north, this is east, this is west, this is south. So what it says? Northwesterly. So this is west, northwestern is this direction. Okay, so it is moving in this direction. I have to join it with the center only, otherwise it will not be 45 degree. Fine. So this is northwest. All right. And then the value is 125. And there is a westerly wind of 50 kilometer per hour. Westerly wind is this one towards west. So that means there is a this one wind is blowing there, this direction, and your plane is going this direction. Fine. So this is the resultant, as we said. Because of the wind, this is the velocity. So where is the actual without wind, which is the direction of the plane? Well, this is the resultant one. So this could be only this one. There is no other direction. This plus this gives me y vector root. This is the resultant. You go this way plus this gives you. Okay. So this is the direction. Direction is fixed. Is that okay? Simple. Is that okay? Direction is fixed. The value you have to find out. How do you find the value? Try to find the value. What is this angle? 45 degree. So use the formula. Already resultant you know, one vector you know, so I can use this formula. Angle is known to you. This angle is 90 degree. So your problem is simpler. The angle between two vectors, one vector is W, this vector is say A. So the angle between the two are 90 degree. So cosine is 0. So it's a right angle triangle. So you have simple formula. This goes off. So we have only this formula. So I have 125 square is equal to 1 is 50 square plus. So you can find out what is the value of B. Some quicker method, 125 square minus 50 square root about 114. Okay. Okay, so let us check it by another method. Can I take the component of this vector along this direction? Should they be equal or not? This is 125, and I take cosine of this vector. Do I get this or not? Isn't it? I take cosine of this vector. It is this one only. Projection of this vector on this one. So cosine of this 125, cosine 45 should give me A. So let us check whether you are getting it or not. A shorter method. 125 cosine 45. Are you getting the same value or not? Let us check. 125 cosine 45. Cosine 45 already known to you. 1 by under root 2. So just multiply. Let us see. 125 under root 2 is 1.41. Are you getting the same value?
So 175.
175. No, cosine 100.
45.
125.
Equal to cos 45.
Not equal to cos 2. 125 cosine 45. So this was this 125 by root 2. Check it whether you are getting or not. You can check. As a home exercise, you can check it. So let us go to the next question. Question number 5.
1.4
Question number 5. Let us go to question number 5. Slightly not very difficult, but draw the diagram first. Question number 5. First read it carefully. So first draw a circle. Okay, and then draw a radius vector. Say suppose it started with some origin point. So let us say it started with this. This r is given. How much? 10. Okay. So after when is 1 hour? So you can take 1 hour. This whole thing is divided into how much? The whole dial is divided into 12 hours, isn't it? So if we take this as 0, suppose, otherwise it's a 3. Is it how much is this? 3. Okay, this is usually 3. So 1 hour after 1 hour. So after 1 hour, it said from a quarter after the hour. After the hour, so let us say it moves to, it is moving in this way. Otherwise, okay, clockwise is this one. Okay, so let us say after an hour it goes to here 4. So your vector is this. Is that okay? And then 2 half past. That half an hour. So that means half an hour over here. So we want the displacement. This displacement is this one. So one vector is like this. The other vector is like this, and you want this displacement. Now displacement or any, displacement or any difference is defined as final position minus initial position. Always remember this. Final minus initial is the difference. In physics, final minus initial is the difference. Okay. So you have to find out what is the difference between this. So this is suppose V vector, this is A vector. So we want to find out B minus A. So either you draw a vector diagram, you use a graphical method, or you use a mathematical method. The only thing is you will have to find out what is this angle. How to find this angle? How to find the angle? Anyway, you know what is the angle? If it takes one round, what is the angle? 360 degree. Okay. So what is this angle from here to here? 90 degree. So, and how many hours are there? In 90 degree, how many hours are? You go to 3 to 6. So you divide the whole thing as, so 4 is, that means 90 divided by 3. 90 divided by 3, isn't it? The whole circle is divided into 1, 2, 3, isn't it? So this is 2, this is 1, this is 12. So 30 degree, they are all 30 degrees. So that means this was 30 degree. Here, this is 30 degree. And the next half an hour, how much? 15 degree. 15 degree. Okay. So the angle is only 15 degree. So you can find the magnitude remains the same. This is 10, this is 10. The length of the arm is the same. So 10 is 10. And then 15 degrees angle. So you can find what is the magnitude of displacement. And then direction you have to find. What is the direction of this one? Resultant. You can use the formula, cosine formula. Tan theta is equal to, tan alpha is equal to, okay, so cosine formula. Okay. So let us go to 6, question number 6. So as we said, we are representing vectors in terms of ijk unit vectors. So let us go to question number 6. R1 is given, R2 is given, R3 is given. So first find the magnitude of R3. Magnitude of R3. R3 is, so there is another notation. All the unit vectors, when we print it, that means in books and printed material, all the vectors are printed as bold face, as I have done it. All the vectors are printed as bold face. All the unit vectors are put as bold with a cap or hat. So this will be bold with a cap or hat. Unit vectors. And any vector is only bold. But when we write it, it is difficult to make it bold and things like that. So we put an arrow over it. When we write it, we put an arrow over a letter to show that it is a vector. So we are not able to write a bold, but when we type it, when we print it, we show it like this. I have not put a cap over I and J and K. So there should be a cap. So these are unit vectors, these are vectors. Fine. And if you want to show the magnitude of A, so either you simply write A or you write it like this. So they will show the magnitude. So what is the magnitude of R3? R3 vector is your minus I plus 2j plus 2k. So the magnitude is, for any vector A, the magnitude is under root component is squares, ax square plus ay square, az square. So find what is the ax, ay and az in this case. 1, 2 and 2. So how much it comes? 3. It comes 3 only. All right, fine. Now what is R1 plus R2 plus R3? Add it. Simply add it. R1 plus R2 plus R3. So I components adds with I component, j components adds with j component, k components adds with k component. Okay. So you can do it without writing also. 3 plus 2, 3 to 5 minus 1, 4, 4i plus minus 2, and then we have minus 4. So that means minus 6.
4i minus 19.
Okay. And plus, how much k is there?
0.
K is 0. So k is 1 and minus 3, that is minus 2 plus 2. So that is 0. So what is the value now? What is the magnitude? What is the magnitude now? Pardon? 32.
Root 32.
Root 32. Okay. What about C? 2R1 minus 3R2 minus 5R3. Multiply R1 by 2, R2 by minus 3, R3 by minus 5. Add it. Write as fast as you can. So speed is also very important in these exams. Speed is also important. So write, you should improve your writing speed. Have you got it? Anybody? Root 30. Fine. So we go to question number 7. Those who have done it. Question number 6. 7 is like this one. Question number 7 is this. Those who have not done it, please do. 6 is simple, so there is no problem. This is just a mathematics. Question number 7. Angle I have given. Without angle, you cannot solve it. So angle I have given 60 degree, 60 degree. Are you following this question or not? So tension, once you suspend a weight, these there are tension in this string. Okay, so this is a T, this is T. So you find what is the components of T, which direction. Now this is T and this is angle theta 60. So what is the component of T along this one, along the vertical direction? T cosine theta is the T cosine 60 is the component of vector along y axis, and there is another component along x axis. So this is T sine theta. Okay, same thing applies for this also. So it will have a component over this one. Let us say it will have a component along this axis and it will have component along this axis. So this is T cosine 60 and this is T sine 60. Now what happens? This T sine 60 and this T sine 60, they will cancel each other. They are opposite directions. And what will add up? These two will add up. So what is the, and then it will be balanced by this W, because this point is in equilibrium, it is not moving here and there. So what is the equation that you can write? 2T cosine 60 is equal to W is equal to, I should write it, not kg, I should write it. If it is kg, then you multiply by say 10, say it is, let us write 1000, let it be 100, approximately 10, g we take approximately 10, so it is 1000 Newton, so this is 1000. So T is equal to how much? 2T is into cosine 60 is half, so T is equal to, no, 2 is there, so same thing, 2T cosine 60 is half, so T, that becomes T, so that means this value is T is only 1000, same thing. Okay, fine. So we go to the next question. Okay, so now this will depend upon, there are vectors, products and things like that. So by now we have understood what is the addition of vectors and subtraction of vectors, how to find the resultant. Unit vectors we have understood. So now we have vector products. So there are two types of products that we define. One is scalar product or dot product. So scalar product is A dot B is defined as magnitude of A into cosine of angle between the two. A dot B is equal to, so suppose these are the two vectors. Okay. Now remember the convention here. The angle is the smaller angle. This is also an angle between the two. There are two angles. You can measure this way or you can measure this way. How much is this? This is 180 minus. Okay. So when we say it is AB cosine theta, the theta is by convention is the smaller angle between the two. Remember this. Theta is by convention the smaller angle between the two. Otherwise, I have this angle also. For a mathematician, the other one is also an angle between the two vectors. Okay. But in physics or even in mathematics, when we define cosine theta, we say it is a smaller angle between the two. Fine. Now, special case, let us take a special case. If suppose they are parallel vectors, they are in the same directions. What is the angle between the two? What is the angle between two parallel vectors? Same direction. Angle is 0. So in that case, what is the product? It is only A into B. And if it is suppose anti-parallel, one vector is like this, the other vector is like this, 180. Then what is cosine 180? It's minus 1. So it becomes minus AB. And suppose the third case, if it is 90 degree, if it is 90 degree, how much you get? How much is you get? 0. So suppose we want to prove that two vectors are perpendicular to each other, or we want to prove that two vectors are parallel to each other, or we want to prove that two vectors are anti-parallel to each other, or we want to find the angle between two vectors. We want to find the angle between two vectors. So we know what is A, what is B, we know what is their magnitude. So if we want to find the angle between two vectors, I can do it, use the scalar product. I can use the concept of scalar products. So again repeat, if you want to find the angle between two vectors, you can use the scalar product. The formula is of scalar product. All right. Some people call it a dot product because of this dot only. This is the answer there. Another name is a dot product because of this dot only. You can call it scalar product. We call it scalar product because the resultant that we get, this one is a scalar. That is why we call it a scalar product. We call it dot product because we put a dot in between the two. Is that okay? So you can prove that two vectors are perpendicular to each other. You can prove that two vectors are parallel to each other. You can prove that two vectors are anti-parallel to each other using this concept. Okay. Even you can find the angle between two vectors using this concept. So let us do this question. Question number 8. So okay, so you need some more formulae. Okay, let us see. So what is the angle between the unit vectors? You already know what is the angle between two unit vectors. After my demonstration, you will never forget. So you have I, J, K vectors. I, J, K. Angle between these two is pi by 2. Angle between those two is pi by 2. Angle between these two is pi by 2. Is that okay? Fine. So if you take a dot product of I with I, what is the value? What is the angle between the same axis? 0. So I dot I is equal to cosine theta is 0, so you get 1. Between the same axis, the angle is 0. So you use this formula. I, magnitude of I is 1. Unit vector, this is 1. This cosine 0 is 1. So I dot I is equal to 1. Same thing is J dot J. Same thing is K dot K. Is that okay? Is that okay? So and then we take cross product and cross dot. So I dot J is equal to same thing J dot K. Same thing is how much? 90 degree. Cosine 90 is 0. Is that okay? So I dot J, I J dot K, K dot I is 0. The other thing is these dot product are commutative. That means A dot B is equal to B dot A. All the vector products like this addition of vector is also commutative. and this scalar product is also commutative. You can write A dot B is equal to B dot A, same thing. Angle between either you take between B and A and B is the same. So let us now do this question. Question number 8. Question number 8. Angle between A and B. So I will use this simply this formula A dot B. Use this formula. So A dot, my A is 2I plus 2J minus K dot 6I minus 3J plus 2K is equal to magnitude of this into magnitude of this into cosine theta. So we want to find cosine theta. First take the dot product. 4. So I take I dot I is equal to 1. So you get 12. So you have got it. 4 everybody. Okay, good. 4. And then what is the magnitude of this A? So 2 square plus 2 square plus, so 4, 4, 8, 9. So let us write it like this. What is magnitude of B? 49. Okay, 49 into cosine theta. So what is this? 3 into 7. So what is the cosine theta now? Cosine theta is equal to 4 by 21. Is that okay? And then what is theta? Theta is simply cosine inverse. What is the approximate value of this? Approximate. You must be able to have some idea. 4 by 21, let us have 4 by 20. So what is 1 by 5? So 0.2. So what is cosine 30? Let us say cosine 30 is how much? 1 by root 2. How much is that? Just find out. Cosine 45 is 1 by root 2. Cosine 30 is under root 3 by 2. So that under root 3 by 2, let us see how much is that. So we write the values, just an idea. So theta, say it is, if it is 0, then cosine is 1. If it is say 30 degree, so this is 30 under 3 by 2. If it is 60, we have half, and if it is 90, we have 0. So this is about 0.2. Let us see where it comes. Between less than 30 or between 30 and 60, under 3 by 2 is how much? 0.85. So we go, that means it is half is 0.5. Okay, so half is 0.5. It is decreasing, so this is 0. So it is somewhere between 60 and 90 degree. It is somewhere between 60 and 90 degree. All right. So that's physics, because many times you will find in JEE and other competitive exams options are given. You have to simply tick the options. So you can argue like this and then find the nearby number, and the options are whichever is nearby this number. You know what is this is between 60 and 90. So whichever is option is between 60 and 90, simply tick it. Every time we don't have to do mathematics from first principles. All right. So you have to go like this also. This as coaching people call it a trick, but I don't call it trick. So it's simply logical and by mathematics and physics. Let us go to question number 9. Question number 9. Question number 9. Question number 9. Everybody should be able to solve each of these questions, at least in my class. Otherwise, the question 9, determine the value of A so that these two are perpendicular. Perpendicular means their product, dot product is 0. So find the dot product, put it 0. Pardon? 3 आ रहा, बहुत अच्छा, very good. So let others find. Speed, as I said, is important, but to begin with, you have to meticulous, go meticulously. Even if you are slow, there is no problem. 3. Everybody. What about this side? You should also be able to get 3. Take the dot product. Use the I dot I and all this formula. Are you getting 3 or not? Okay, fine. So let us go to the next page. Okay, good. Okay, this question is different. Find the projection of the vector A on the vector this. So projection means this thing. I have a vector over here. Try to let us understand it. And then this is a vector A. This is my I-axis, X-axis. This is my J-axis, Y-axis. So projection of this on this, that means on this. So usually you write it AX. So you call it AX. AX is equal to how much? A cosine theta. If this is theta, so this is A cosine theta. On this, the projection is A sine theta. But you are getting this because this is I-axis, X-axis. If it is something different like this vector, if you are asked what is the projection of this vector on this vector, then you have to find the dot product. Projection of this is dot product only. So you find the dot product, you get it. Find the dot product, you got it? Okay. So go to the next question. Those who are moving faster, do the question number 11. What is the work done formula? Got it? The question number 10. Everybody got it? You should agree with each other. Are you getting 19? Okay. So let us go to question number 10. First we define what is the work. Work done by a force. You already know what is the work done. Work done is the force into distance. This is a simple formula. But sometimes force may not be in the same direction. So you have to use the vector notation. This is the force. This is the displacement. So it is dot product between the force and the displacement. So find your along a vector, vector is given and force is given. So simply a dot product between the two. The dot product between the two will give the work done. Find the dot product. Find the dot product between the two. How much you are getting? 9. Everybody? Others also? 9. Good. 9. What is the? Okay, we have not given any unit. All right, fine. Well, if you want to make this question slightly better, so what do you put? Force is in Newton. So force is in newtons, and R is what unit should we put in this question? R is in meters. So I should write, if I want to refine this question, I should write like this. R is equal to 3I plus minus 2J minus 5K into meter. I should write like this. If I want to refine this question, I should write like this. For a mathematics person, this is fine. Units are not given, this is fine. But for a physics person, if you want to refine this question, I will write it meter outside the bracket. R is in meters. You define it. And then force is in newtons. That is what we are saying. So put the whole thing in bracket and write a Newton here. Sorry. In force is in Newton. And work done is how? What is the unit of work done? Joule. Okay. 9 joule. So that makes sense in physics. Otherwise, so now we come to another product that is known as vector product. So we have two vectors, A and B, and we define a vector product by this. So sine of angle between, this is another symbol that we use in some books. Sine of A, angle between A and B, A comma B. Sine of angle between the two, okay. And then now this vector product by definition is a vector. Is a vector product of two vectors. That is why we are calling it a vector. It is defined by this. Then what is the direction? This will have a direction. So let us say n, we write n unit vector in that direction. Magnitude of the vector product is magnitude of A cross B is AB sine theta, and direction is, now we define what is the direction of A cross B. Define is, the direction is perpendicular to both A and B, perpendicular to the plane containing A and B. Like I will take a simple example. Let us take I, J, K vectors. So our I is this, J is this, so I cross J will go to K. The value of I is 1, the value of K is 1, unit vectors. So I cross J is K, okay, fine. Similarly, J cross K will be, so to remember it, or K cross I is J. So just to remember it, we put a circle, write I, J, K, go clockwise. So if you just remember, just for remembering, if you are taking I cross J, you get K. If you take J cross K, you get I, you get K cross I. Okay. If you go the other way, you get a minus sign. If you go the other way, you get a minus sign. Fine. So, and then we have again used the same convention, right-handed. Because this n could be anyway, it could be K also, it could be minus K also. So you have to adopt some convention. So that convention is right-handed. So we take, that means from A to B, suppose these are two vectors, this is A, this is B, we go from A to B in a right-handed way. So we go from A to B, and then we have a right-handed screw that will move in this direction, upward. So that is the right-handed means of right-handed. Oh, A cross B, C is equal to A cross B. What is the magnitude of these two vectors if they have ijk components? So there is a not in your CBSE textbooks, but we should know, for you we should know, this is known as A cross B in component. This is known as determinant. You should better know it. Simple. This is a simple one. So I write it Aij K. Then I write the components Ax, Ay, Az. All right. Then I. What is the value of this one? Let us write it. So this is known as determinant. This is known as determinant. It is known as determinant. Yeah. Question number third. Okay. From which? Third from my question bank or from this list that we are showing? Okay. Can we go to question number third? Okay, fine. Can we go up, please? Yeah. Should we repeat it, ma'am? Question number 3, find the sum or resultant of the following displacement. Okay. Let me, okay. So we have already solved it, maybe we did not get it. Okay. So we just first identify the directions. So 10 meter northwest, already I have defined in the beginning. What is northwest? Northwest is, suppose this is origin, so northwest is center of this northwest, so this is the northwest with 45 degree with the horizontal direction. Okay, so this is northwest, and then we have 20 meter 30 degree north of east, 30 degree north of east, so this is east, this is my east, then 30 degree north of east, so this is one, this is my 30 degree north of east. Is that okay? 30 degree north of east, so this is the another vector, and then we are going to 35 degree due south, so that means from here we are going in this direction 35 degree, sorry 35 meter. So you have to first, there are three vectors, one is this direction, so one vector is in this direction northwest, this is 10 meter, this is making 45 degree with this, then we are going 20 meter 30 degree, 20 meter we are going northeast. Okay, so we are going this way 30 degree, so that is this, so 30 degree is this angle, so this is the vector we had talked about. So what is the resultant of these two? First find what is the resultant of these two, what is the angle, this 45, so this is again 45, so the angle between these two vectors are 75. Find, use the formula, this one, r square is equal to a square plus b square 2ab cos theta, cos is 75, angle is 75, sine, and we find that it is in this direction. What is the, you find what is the value, you want to find the direction of this, find, let us find the direction also. What is the resultant one of these two, find what is the resultant of these two, we are only finding the, asking for the magnitude. Okay, and then there is another vector in this direction. Okay, so now there could be a question, yeah, So whether it is in this direction, what is the direction of the resultant? What is the direction of the resultant? One vector is in this direction, the other vector is in this direction. So you have to join these two. All right, this is 75. Okay, so one vector is in this direction, the other vector is in this direction. So what is how to find this angle? This is 75. This is the resultant. Okay, so what is how to find this angle? Theta, alpha, let us say. Can you find? There are two vectors. One is this vector, the other is this vector. Pardon? Achha. So this is one vector, the other vector is in this direction. So you have to find the resultant. This is 75 degree. So what is the angle? This angle. How to find this angle? What is the angle? How to find? Angle between resultant, angle between resultant and this vector. So let us complete the parallelogram. Okay, so let us complete it. This is one vector. Let me do it. One vector is this. Okay, now you are drawing the other vector from this is in this direction. Right? It is okay. It is going from here. So I will do it in a meticulous way. Let us take it the vector as component method. Let us take the vector as component. Simplest way to do is to take it component. Graphically, let us not do it. We take it a component method. So this is how much? How much is this? 10 or 20? 10. Okay, 10. And what is this angle? This 45 degree. Okay, so this 45 degree. All right, and this is 10. So what is this? This is my I vector, I minus I. Let us take it as minus I. I am assigning, I am doing it now very meticulously. So let us say I, this is J. Fine, I and J. So my vector is 45 degree and magnitude is 10. So what I do, my vector, this vector A is equal to, A is equal to, I will write it 10 cosine 45 into minus I. Is that okay? I am doing another method. Is that okay? This is a minus I only now. Plus, it will have component in this direction. So that is how much? 10 sine 45 into J. Is that okay? Is that okay now? I'm okay. Are you getting it? Another question. Okay. Another question, please. From which center? Pardon? Itanagar. Yeah, please, please. Okay, okay, please. Yeah, I'm coming. Just first question number 2, 3 we are doing. Let me complete 3, then I'm question number 5 also we will tackle. Question number 5 also will do. Let me do this one. A is this, and then what is B? Vector B, I am writing first another method we are doing. What is vector B? Vector B is, this angle is 45, sorry, this 30, this 30. So my vector B is, this one is, B is equal to, if you have any doubt, it is better to use this method. B is equal to, this is 20 meter, 20 cosine 30, and what is the direction? I. Is that okay? Plus, I will write 20 sine 30, and what is the direction? One is this way and the other is upward. So J only. So J only. All right, you got it. And how to find the angle between these two? Now there is no confusion. Angle is simply take the dot product. Angle is simply take the dot product between these two vectors. A dot B, simply take the dot product, is equal to magnitude of A, magnitude of B into cosine of theta, and then find what is theta. So question number 2 can be settled now. You can find what is theta and whether it is in southward direction or not. All right, you can do it now. No, my theta is defined with reference to x-axis only. All right, so you can find what is the theta. Angle between the two you can find. Okay, now question number 5. Can we go to question number 5? Can we go to the question number 5? Yeah, question number 5. Question number 5 we did it. Okay, so first try to visualize the situation. What is the situation? We have a minute. Okay. So okay. So it's a minute hand, not the hour hand. It's a minute hand. So minute hand, we have already done it. We did it as an hour hand. So minute hand is how many? 60 minutes. 60 minutes it takes one circle. Okay, so minute hand of a clock measures 10 centimeter. Okay, so let us say this is 10 centimeter. Okay, what is displacement vector of a strip from quarter after the hour to half past after an hour? If it is a minute hand, after an hour it comes over here only. 1 hour it takes. In 1 hour it takes the whole circle. If it is a minute hand, in 1 hour it takes the whole circle, one revolution. So it comes over here only, and after this it goes to, after the hour, to half past. Half past an hour. After an hour, what is this? That means half an hour means how many minutes? 30 minutes. So after 30 minutes, where it is this one? This is 15 minutes. So this is, so it will be here. Is that okay? Is it clear now? Previously we did it as an hour hand. Now we do it and minute hand. Let me repeat. This is a minute hand. A minute hand takes 60 minutes for one revolution. Okay. So this is, that means in 15 minutes it is over here. This is 15 minutes. This is 30 minutes. This is 45 minutes. This is 60 minutes. So it says 1 hour. What is displacement vector of strip from a quarter after the hour to half past, from a quarter after the hour, That means after the hour. Quarter after the hour means quarter of an hour is how much? 15 minutes. So 1 hour is this, and quarter of that means it is over here. Again read this question. From a quarter after the hour. After 1 hour, in 1 hour it comes over here only. Quarter is 15 minutes, so it is this position. All right, and then it goes to half past. Half past means after this position. Half past means another 30 minutes. So half past is coming over here. Is that okay? So what is the displacement now? From you have gone from OA to OB. One vector is this. What is the displacement? How to find the displacement? First represent what is the vector here. How to do it? First thing, best way is to use the component method. I assign a I direction in this direction, J direction in this direction. So this is how much? Is 10 centimeter. Okay. So I put it in meters. So 0.1 meter. Okay. So this is what is this OA vector? OA vector is 0.1 into I. Is the okay? And then what is OB vector? Is 0.1 into what is the direction now? Minus I. Minus I. What is the displacement? OB minus. Isn't it? We go by basic physics. OB minus OA. What is this? Is that okay? Any question? What is this? How much you are getting? 0.1 into so this what is the magnitude of this displacement? What is the magnitude? Magnitude is 0.2 square or only 0.2. Magnitude is 0.2. And what is the direction? Minus I. Is minus I. Is that okay? Any other questions? Okay, fine. So which question we were doing? Vector products. As I said, whenever you have a confusion, it is better to use first principles. It may be longer, it may take more time, but then you are sure about your results. As we did for angle question, it's better to write everything. So we were discussing about vector products. A cross B is defined by a determinant which is equal to I. Now you see the convention. If we take I, forget about this row, just block it and then multiply these two. This into this minus this. All right. This into minus this. If we take J, so I write it A. So I, this is AY, BZ. Again, I repeat, those who are new to this, if I take I, forget about these rows, you take A4 into this minus A this. Is that okay? And then you change the sign minus J. Forget about this row. What is left is this and this. So you don't change the, you always do it from left to right. So AX BZ minus BX AZ plus K. Again you take K, so forget about these rows. AX BY AY. So what is X component of this? Let us see what is the X component of this. X component is, let us say this is C vector. So X component is Cx is equal to how much? Whatever you get as multiplier of I, that is X component. So Cx is equal to AY Bz minus this Cx. So similarly you have Cy You have Cz, Cy and Cz.
Yes.
And if you want to write the whole C, then how do we write it? C is equal to C is equal to Cxi plus Cyj plus Cz. All right. So as I said, what is the direction? It is a right-handed direction. So you have A cross B is equal to magnitude of A, magnitude of B into sine theta into the angle between the two into the normal vector. Whatever is the normal vector perpendicular to these two. So we have a question number 12. You have to find A cross B, B cross A, and then other thing. Now because they are not commutative, these vector products, they are not commutative. A cross B is not equal to B cross A. A cross B is not equal to B cross A because of this. So A cross B is equal to what it is equal to is minus because of this normal, so sometimes this direction is different. It is a k direction, and if you take B cross A, it is minus k direction. So because of the direction only, magnitudes are the same. A cross B and B cross A, the magnitudes are the same, but the directions are different. The magnitudes of this is equal to but directions are not same. Directions are different. That is why the vector is different. Okay. So we do a question number 12. Question number 12. A cross B. First we find A cross B, then B cross A. As I have already told you the rule for IJK. Can we have more markers, please? Markers. So I cross J is K. You remember this circle? I cross J, you go clockwise only. I cross J is K, J cross K is Y, K cross I is J. The other way, opposite way, it is minus sign. Okay. So do question number 12, A cross B and B cross A. A cross B and B cross A. So what is I cross I itself? We have already said I cross I. What is the angle? I between I and I is angle is 0, and it is sine angle, sine of theta. So this is 0 only, is equal to also J cross J is equal to K cross A. They are all zeros. The angle is 0 between these two. So question number 12, let us do it. A cross B. A cross B. What is A? A is 2I minus 3J minus k cross what is b, I plus 4j minus 2k. So the best way is to write the determinant. Shorter way is to write the determinant. We write the determinant only. So we write I, j, k. Write the determinant only. Just write the determinant. So this is 2, this is minus 3, this is minus 1, this is 1, this is 4, this is minus 2. All right. Then find the values. So I take I first thing is I, and what are the values? Minus 3, minus 2. So that is 6 minus this is 4. So 6 plus 4 minus j. I take j. So 2 into minus 2 is minus 4 minus plus 1 plus 1. Is that okay? And then k is this. So 2 into 4 is 8. 8 plus 3. So what is this value? This is equal to 10i plus minus this is plus 3j plus 11k. Everybody is getting this value? Everybody getting this value? Okay. So A cross B is this. What about B cross A? Again we do the same method. B cross A, your B is, write this determinants changes. So these values change. What is B is first? B is your 1, 4 minus 2. The other is 2 minus 3 minus 1. So find what is these values. So I 4 into minus 1, that is minus 4 minus 2 3, that is 6. Is that okay? Then j, this is minus 1 and then minus 2 minus 4, so plus 4. Okay. Then k, so minus 3 minus 8. So how much you get? Is minus 10i minus 3j. Is it equal to minus A cross B or not? It is equal. So that verifies the formula. So A cross B is also minus B cross A. Then you have to C part. C part. I just delete. C part. Okay, C part. What do we do? These are these things. A cross B cross A minus B. It is given. Oh, sorry, not B minus. A cross B, A plus B, and A minus. These are okay, not these things. Okay, so A plus B. A plus B. What is this A plus B? Add it. A plus B, I 2 and I. So 3I. Okay. And minus 3 and plus 4. So plus 1. And then minus 1 minus 2 minus 3. Okay. And then the other is A minus B. What is A minus B? 2I minus I. So you get 1. And J component minus 3 minus 4. So you get 7. Is that okay? And then minus 1 minus 2 plus 2. So you get 1 plus 1. Is that okay? Then substitute the values here. So 3, 1 minus 3, 1 minus 7. All right. Then values, put the values here. So 3 into 1 is 3. And minus 3 into 1 is minus 3. So plus 3. J, how 3 into 1 is 3. And minus 3 into 1 is minus 3. So plus 3. Is that okay? And then K, 3 into 7 minus 21 plus minus 1. So what is the value? 6I minus 6J minus 20. Is that okay? So we go to question number 13, simple one. A unit vector perpendicular to the plane of these two. So we are using the concept of vectors. Question number 13. Question number 13, how do we do it? By definition, the cross product has a unit vector which is perpendicular to both vectors. All right. So take a cross product of these two, A cross B. A cross B is a vector which is perpendicular to both A and B. So let me write what is A is 2 minus 6 minus 3 and the B is 4, 3 and minus 1. So okay. So what is this? I 2 minus 1, that is minus 2, and 12, so minus 12 plus 12, minus J minus 2 plus 12 plus K minus 2 plus 12. Is that okay? Any? Okay, so just a minute. I is equal to 2 into minus 1. This is okay. 4 into 13, 12 is okay. What about this one? J is okay. So minus 6. Just a minute. Minus 6 into 1. So is equal to plus 6. Okay. Plus 6 and then minus. Okay, just a minute. Plus 9. Okay, just a minute. Good, thank you. So minus 6 into minus 1 is 6. Okay. And then this is minus 9. So plus 9. Is that okay now? What about J? J is 2 into minus 1. So minus 2. Minus 3 into 12. So minus plus 12. Is that okay? And then let us K is 2 into 3. So no, 2 into 3. 2 into 3. So 6 plus this is 24. So what is the total? 15I minus 10J plus 30. So this is a vector which is perpendicular to both A and B, but this is not a unit vector. He is asking for unit vector. So this is the direction is okay for this vector. That is which we want the unit vector. So what is the unit vector in this direction? Divided by the magnitude of this vector. So that means let us see, this is C. So n is equal to, or say C unit vector is equal to C divided by C. Okay. So what is the magnitude of this? I write 15I minus 10J plus 30K. Magnitude of this 15 square plus 10 square plus 30 square. Is that okay? 35. Good. 35. So that means I have my unit vector is 1 by 35, 15I minus 10J plus 30. Can you simplify it once more? Can you simplify? 1 by 7. So I have divided by 5. So 3I minus 2J plus 6K. All right. So this is the answer. Go to the next one, question number 14. Question number 14. A particle moves along the curve, its velocity and acceleration. Okay, so we have come to differentiation. We are coming to after that. So vector product and scalar products are okay. Then you have the differentiation and integral of vectors. So let me define now. Velocity is usually defined by, let us say, displacement divided by time. Is this definition okay? Delta x is the displacement, delta t is the time. But this is the average velocity. Instantaneous velocity will define like this. Okay, dx by dt. You have to take this is the displacement. This is a vector. It's not usual differentiation. Usual differentiation is number differentiation. Like x square, you differentiate x square with respect to x. How much you get? 2x. So this is not a number differentiation, it is the direction also is involved. So suppose my vector is r. So this whatever is displacement vector, suppose a particle moves from r1 vector. So let us say this is r1. This is the origin, and it from this point it is moving to another point, let us say r2. This point is q. Okay, so the displacement is this one. Displacement is this one. So this is also a vector. Now you find it is a vector. It's not only a number. And this vector is not in direction of this or this. This is also a vector. So r2 minus r1 is a vector. Is a vector. All right. So you have to find that, differentiate this with respect to time. You have to differentiate this with respect to time. That is what we are trying to find out. So first find what is r2 minus r1 and then differentiate it with respect to t. So let us go. This is slightly difficult question, but let us do it. So first x is given, y is given, and z is given. So its velocity and acceleration we have to find in the direction I minus 3. First find what is the velocity. How to find velocity? First, we do not know what is the vector itself, what is x. X is given, but in which direction? In which direction? Direction is not available. So how do we construct the direction? X, Y, Z direction we know what is the unit vector. X is I, y is j, and this is k. Okay. So what is your vector? What is your vector? Displacement vector. That is this vector. Vector is, you first define that vector. So my vector is, say r is, let us say 2t square I. Okay. I multiply x by I, then I multiply y by j. So I should write, let us first write it, xi plus yj plus zk. Is that okay? That is the vector. Okay. Now I put the values. So x is equal to 2t square I plus t square minus 4t j plus 3t minus 5. Okay. So this is my r vector. So if you want to find velocity, what is the velocity? Velocity is simply dr by dt. Dx by dt or dr by dt. Okay. So this simply differentiated with respect to time. If there were no time over here, suppose there were no time over here, so you will get 0, 0. So because of the time, there is a, you can see differential value is there. So what is dr by dt? So you find this factor is 2t square, so 4ti plus what is, how much is this? 2t minus 4 plus 3. All right. Now this is velocity I have got. So velocity I have got. Now what is the acceleration? How do I define acceleration? Again differentiate it. Again differentiate. So do it. So find what is a. First find the general expression. Find what is a. So my a is, differentiate it. So 4i plus 2 j cap. There is no t here, so you get 0 only. So what you find is acceleration is in the ij plane. Acceleration is in ij plane, while the velocity is in ijk plane. Okay, so that is, you see the direction has changed. Acceleration is in a different plane, ij plane, while the velocity is in ij and k plane. Okay, so what is the question? What is the question? Find the components of velocity and acceleration at time t is equal to in the direction this. So you have to find the component in this direction. That means you find the dot product, projection of dot product of this v with this vector. Find the dot product of v with this vector, and then find the dot product of a with this vector, and then put the value of t is equal to 1. Is everybody is getting? Slightly difficult question. Everybody is getting? Okay. What we are saying is components of its velocity. That this is a velocity, and you want to find its, what is the component of this velocity along x-axis? Take my question. What is the component of velocity along x-axis? 4t. What is the component of velocity? Because how do you get it? You know it, so you get it, but doing mathematics, I will do it like this. 4t, this is the vector, and they take a dot product with I. This is the vector with I. Vector along x direction is I only. So I am taking dot product of this. Okay. So that is what we are saying. How much you are getting? 4t. That is what we told in the very beginning. The component of this vector along x direction is 4t, because I dot I is equal to 1. So component of this vector along z direction is 2t minus 4. along k direction is 3 because k dot k is 1. So if you want to find the component of this vector along the given vector, you have to take a dot product only. So you take the dot product and put the value of t is equal to 0, all right. And then take the dot product of this vector acceleration with that direction, with that vector, and keep the value of t is equal to 1. Is that okay now? You get it, everybody? Second part, acceleration also you're done, and substitute the value of t is equal to 1. So we have not to substitute the value of t in the beginning, do it only in the last stage. Go to question number 16. Question number 16, 14, sorry 14, okay, 14, okay, we have to go to 14. Okay, question number 14. Okay, good question. Yeah, this is something we are taking it to slowly to the J level, your JE level. There is another name for these equations, parametric equations, where x depends on some x and y and z depends on some other things. Then you have to first write the radius vector. First write the radius vector or the position vector. What do we do? R is equal to xi y plus jk. X is given. X is equal to how much? X is equal to e minus 3. Okay. 3 there's okay. So all right. Let us take what I think let us take t value also. 3t. Maybe there is some misprint. We take 3t and y is equal to 2 cos 3t. Let us do it the way it is given. We will solve it, modify it. And y is equal to 2 cos 3t and z is equal to 2 sin 3t. So what is your position vector? What is the position vector? Position vector is xi plus yj plus, so substitute the values. Is that okay? So substitute the values, e minus 3i plus 2 cosine 3t into j plus 2 sin 3t into k. All right. So you have to differentiate this. You want to find the velocity. You want to find the velocity at any time t. So differentiate with respect to t. So if you differentiate, velocity is dr by dt. What is the first part? First part will give you, there is no t in the first part, so it will give you 0. Second part, cosine 3t is how much? Minus 2 into sin 3t into is minus 3 you get. So 3 you get. Is that okay? So this is j. And what about this? Plus 2 into 3 into cosine 3t. Is that okay? Cosine, you differentiate cosine 3t. Cosine 3t is sin 3t minus sin 3t into the argument sin 3t. So you differentiate 3t. 3t gives you 3. Is that okay? So cosine 3t is minus sin 3t into 3. So this gives you 6 sin 3t I j plus 6 cosine 3t into k. So this is the velocity. What about acceleration? And you have to find velocity at what time? Okay, let us come. General expression determines velocity and acceleration. What is acceleration? Differentiate this one more time. One more time. Okay, so there will be some interesting result here. One more time we differentiate. So how much you get? So minus a is equal to minus 6 into 3, that is 18, cosine, yeah, cosine 3t, is that okay? Minus 18 sine, is it okay? Now first part is okay, determines velocity and acceleration at time. Find the magnitude of the velocity and acceleration at time t is equal to 0. So do it. What is the value of velocity at time t is equal to 0? So first find v is equal to, at time t is equal to 0, how much? Sine will give you 0, cosine will give you 1 value, so 6k. What is magnitude? 6 only. And what about acceleration? Acceleration value of acceleration vector is at time t is equal to 0 is equal to minus 18i. And what is its value? And magnitude, sorry. So its value 18 only. Minus 18 or 18? Very sure? Okay, good. So let us go to question number 15 we have done. Okay, 16 we go to 16. Question number 16. Let us do it. R is given. Very good question. R is given. You have to find the velocity. Same thing that we have done right now. Differentiate it with respect to t, you get velocity. Again differentiate it, you get acceleration. Everybody is familiar with differentiation and integration? Basic one? No problem? Okay. So differentiate this with respect to time. So R is given. So what is my V? I do straightforward. What is V? V is how much? Minus omega cos omega t. Differentiate, you get sin omega t into omega t. So different, that gives you omega factor, omega sin omega t, and then you have I value. So always better to put it like this. Either you put this one, so that there is no confusion, plus cosine omega t into j. Is that okay? And what about acceleration? Again differentiate it. So it becomes minus omega square cosine omega t Is that okay? So first part you have got the velocity, second part you have got the acceleration. So that velocity v of the particle is perpendicular to r. Where r was R is this one. So how do we prove that R is perpendicular to V? We take the dot product, and if it is 0, it is perpendicular. So just take the dot product. R dot V. R dot V. I dot I, you know, what is I dot I? 1. So you multiply this cos and sine. So this is minus omega sine, and then j dot j is again 1. So you get plus omega sine. What is this one? Is this 0 or not? It's a 0. So this means R is V is perpendicular to. Is that okay, everybody? Everybody okay? All right. So V is perpendicular to R. What is the second part? The acceleration is directed towards the origin. So acceleration already we have found, and has magnitude proportional to the distance from the origin. Let us look at the expression for acceleration. Let us examine this expression. You can write it like this also: minus omega square cosine omega t I plus sine omega t j. You can write this again as A is equal to minus omega square. What is this bracket sign? It's only R. In the bracket we are getting only R, so omega square R. All right. Now what is, yeah, pardon? Repeat. Okay. So what I am doing, I am examining the expression for A. So A is this one, that is, we got it. So let us take omega square out, minus omega square out. So minus omega square, what is left is cos omega t into y. Here what is left is sin omega t into y. And what is this bracket thing? This nothing but R. R is equal to this only. So I can write this as minus omega square R. Now what is the direction of A? My R is from the origin to the particle. This is R. What is minus R? Towards the center. Minus R is towards the center only, isn't it? So the magnitude is omega square. Magnitude is omega square. So acceleration magnitude is omega square. Direction is towards the center, not opposite. Again, we will not talk about downward, upward, opposite, and no. Towards, you specify towards the center. Towards the center. And what type of this force? Acceleration is this. What is the force now? Force is equal to how much? Mass into acceleration. What is this one? What is the direction of this force? Towards the center. Is there any special name for such forces? Centripetal. Centripetal force. Forces which are directed towards the center, they are known as centripetal forces. So this is an example of a particle moving in a, what is cos omega t and sin omega? Let us visualize it. What is this? This is mathematics we have done. We have solved the problem, but a physicist is not satisfied unless he can visualize the whole situation. So let us visualize it. Let us write R. Where is R? This is my I. This is x-axis, so this is I. this is j, y-axis. Then your vector r is this. Let us say this is vector r. Let us say this is, let us say it is omega t. So after time t it is here. So this is omega t. If omega is the angular velocity, okay. So in time t, what is the angle described by it? Time t is, this is theta angle, and theta is equal to omega into t by definition. What is angular velocity? Theta divided by time. So my theta is equal to omega into t only. What is the projection of this on x-axis? R cos theta. Okay. And the what is the projection on j-axis? R sin theta. R omega t. So what is the motion of the, what is the path of the motion of the particle? It is nothing but a circle. So it is a circular motion. This one is circular motion. R is equal to cos omega t I plus sin omega t I is a circular motion. Okay. It is a particle moving in a circle. What is the magnitude of this position vector here, given here in this question? Magnitude of the position vector. What is the radius of the circle in this question? Radius of the circle in the given question. Cos omega square t plus sin square omega t is 1. So radius is only 1 meter or 1 centimeter, whatever. So radius is 1. I can modify the same question. You will get the similar answer. I can write it like this also. R is equal to R0 cos omega t I. Okay, give any radius. You can give any radius to this value. There is no problem. You can give any radius. Let us say I can give a value 5. So the radius is 5. And a good paper setter will write here in meter, specify the unit, because R has a unit. A good paper setter will write the unit of R. R has a unit of dimension of length only. So either you write meter or you write centimeter or whatever you want to write. So a good paper setter will write like this into meter or centimeter and things like that. All right. Then last part of the question, R cross V is a constant vector. What is R cross V? Find out. What is R cross V? R cross V. V already you know. We have already found what is V. So R cross V, take the cross product. Take the cross product. Take the cross product. We found already V. R is how much? R is equal to what is V? V is equal to minus omega Okay, so there is no k vector, so we can write it 0. You can straightforward find what is the value. What is the value you get? R cross V is 0. Okay, so you are getting 0. So I sine 0. Okay, so you are getting 0, and then J. Okay, J also you are getting 0, and then K you are also getting K. K is but there is a K here. K is not 0. K is not 0. है K तो K factor तो रहेगा आपका. So it is not 0. It's not 0. K is equal to, so I component is 0. 0 J component is 0. And what about K component? K is not 0. K is not 0. K is how much? Omega into cos omega square t plus minus plus omega sine omega. Is that okay? So what you are getting is omega k. It's not 0. It's not 0. R cross V. Why he has asked this question? It's a constant vector. He says, is it a constant vector? Why? Because omega is a constant. Already he has said in the second line where omega is a constant. So this is constant. So the vector is a constant. K is also constant. Why he has asked this question? What is the importance of this question with reference to physics? If I multiply this velocity by V, a mass, what is physical significance of this question? If I multiply with this velocity by mass, what is this? Mass into velocity is a quantity known as momentum. And momentum, you multiply, momentum is known as angular momentum. So this is a new physics quantity. This is angular momentum. Denoted by so that is why this question is designed. So angular momentum is, you can see, angular momentum of a particle moving in a straight line. How much is that? Particles moving in a straight line, you know what is their momentum? Suppose the particle is moving along a straight line, let us say y-axis, x-axis. The particle is moving along this direction. What is the velocity? Let us say it is v velocity. Okay. What is its momentum? Mass into velocity. So mv. What is its angular momentum? When you say angular momentum, that means there is a property of angle. So it is a property of rotation. So whenever you say angular momentum, you have to specify about which axis. Like I am asking angular momentum of this pen, say about this axis. So it is rotating like this. Okay, so you have to specify the axis or the origin also. So angular momentum about this. If you draw perpendicular from this to this line, it is 0. Angle is 0. But suppose I shift the origin here. My origin is somewhere different. It is not on the line. So this r vector is also in this direction and v vector is also in this direction. So what is r cross p for this case? R cross p is equal to how much? For this case, r cross mv is equal to m, we can take out r cross v. What is the angle between r and v? What is this definition? M r v sine theta. What is the angle between r and v in this case? 0 only. So 0 only. So for a particle moving in a straight line and about the origin, the angular momentum is 0. But suppose I shift the origin. Suppose I shift the origin. I am talking about the particle is moving in the same direction. But my origin is here. Particle is moving in the same direction, but my origin is here. The particle is moving in the same direction. V vector is there, but your r vector is this. Pardon? 11:30 is 12 now. Okay, 11:30. Okay, so what is the okay? So okay, so this is the I have shifted the origin. So what happens? R cross V now. R cross V is now, you can see there is an angle, and there will be non-zero angular momentum. In this case, there will be non-zero angular momentum. So we'll talk this about when we talk about mechanics. Okay, thank you very much.
you're doing a sample of ore. Ore, you know what it is? From which a metal is extracted property. Where is the underlying property? So you have to find out what is that metal concentration also. That comes the later part, quantity. Quantity, how much is the quantity? Suppose magnesium is there in a particular sample. Magnesium is there. How much magnesium? Or there is a mixture of something. You want to find out calcium, how much calcium is. That comes the role of quantity. So in the analysis part, we will divide it into qualitative and quantitative. Qualitative, we have different schemes. Okay. You have dealt with the one aspect of it already, gravimetric analysis. As the name suggests, gravimetric analysis. What does this give you? Gives you a ring in your ears? कुछ बचता है कानों में कि gravimetry. What is it? What is the principle involved in it? So the name would suggest you this thing, the principle. Gravity. How come gravity? Some solid substance is going to be precipitated out under the influence of the gravity, and that's why the name gravimetric analysis. You understand? In this case, this is another method of analysis where you're going to find out the concentration of an unknown substance in any given mixture or any ore or anything. So the name suggests volumetric analysis. What does it suggest? You have to measure volume in this case. Volume of what? Or the solution. So that's what we are doing in this case is we will be talking about the this particular analysis in solution state. Maybe liquid, maybe aqueous solutions, or maybe non-aqueous solutions also. It can be anything. Basically, in your syllabus, I suppose in your class 11 syllabus, you will be doing experiments regarding what? Redox titrations. Titrations. What are titrations? So the volumetric analysis, the earlier name was volumetric analysis. Still it is also being used, volumetric analysis. But now we have changed it to titrimetric analysis, titrimetric. So the name titration comes. This name comes from a French word, titulus. Titulus, it means inscription or a title. It doesn't mean anything. But we have adopted this titration, and you have two solutions, one of a known concentration, another of unknown. So by manipulating, by doing a titration, you will find out the concentration of a unknown. Is it? It's very simple exercise. And the beauty of this thing is that this particular volumetric analysis is that you really can do this analysis or finding out the concentration of unknown concentration. You know that particular substance is there, but how much it is there? That by a very simple technique, very simple, very easy to handle, less costly, doesn't involve much of money also. It will involve what are the various apparatus. You are familiar with that, or do I have to tell you? The apparatus involved in analysis, volumetric analysis, would be involving a burette, seen burette, a graduated cylindrical tube where the markings are there, and these markings are for what? For the measurement of the volume of the solutions. Actually, these measurements, because the radius of the cylindrical would be varying from one burette to another. So the markings may be changing. What we are interested not in exactly in the marking, but the difference. Difference is the unit volume. So 10 is written here, 20 is written here. You have seen this. If you in this tetrametric analysis, you will find that some bullet. Uh, so these are the few terms which you are supposed to be familiar with it. Are you familiar with this? No. The titration involves a burette and a pipette. Have you seen pipette? I'll show you during this course. This will be depicted here. It will be in figure. So you take a known volume of a solution of a known concentration and an supposedly an unknown concentration, and the volume is known. So out of these four things, three things are known, and the fourth thing you are going to find it out. Now, by a very simple technique, not involving more than 100 or 200 rupees. Burette would not be costing you much. Pipette wouldn't be costing you much. You would be needing a conical flask. Conical means cone, and you would be needing a beaker and a few or glass apparatus. While analysis of the sample in the modern times would require millions of rupees. Why? Because it's an instrumentation, and the instrument costs, and you have to maintain that instrument. You see, the instrumentation is a black box for you, but the principle, underlying principle, would be the same. We just switch off and then say, oh, this is the titer value. But this is, again, you may not be knowing the underlying principles involving what you're exactly doing. Even a small boy, a 5-year-old, also can switch on and find it out the titer value. But he may not be knowing what exactly is the reaction which is going on. And if he's, he can't think about it, but you can think about it. Being a chemistry student, you would be doing that. What I have to do if an unknown problem comes to you? How do you manipulate? How do you manage? How do you, what is the underlying principle involved in it? Basically, it is simple. Unknown concentration and a volume, fixed volume, you know that. Known concentration and the volume also known. So out of these four things, one is unknown. You can find it out that easily by simple calculations, right? Now, this involves, we can start from the beginning, and I'll just give you the brief. What is this? This is the tetrametric analysis. How do we proceed? But first thing I must emphasize on this thing, that this is a very simple method, accurate also to some extent. Within 1% error, you can find out the concentration. You know what is concentration I'm talking about, right? It can be expressed in many units, of course. But the only thing is that simple, precise, reproducible. Means if I'm doing it here and somebody is doing it there in a different place, he would be also coming with the same results. And that's very important. Otherwise, your results will be of no use, no consequence. If your results do not match with the actual, or somebody is doing a titration in here, somebody is doing the titration in Nagaland, the temperature difference is there. But here in this particular simple technique, we have a wide range of temperature in which you can perform this titration, and you can find out the concentration very easily and not bothering about the temperature changes even, though it may have some effect. A slight amount of error would be there if you're doing a titration in Kashmir or something, but they cancel out mostly. The temperature effect and these effects do cancel out because you are taking two solutions and you are using the same terms and then canceling out. So it is a versatile thing, can be used almost by anybody, and you can manipulate, you can, if there's some unknown thing is there, you can use your brains and devise a method of doing a titration. किसको इसको किसके साथ titrate किया जाए? ये मेरे पास solution है. What are its property? What is the property of that substance who is supposed to be found out? Now you have to find out that particular substance and then say substance है क्या? What is this substance? Suppose I give you an example. आपके पास एक antacid की tablet आ जाता है. You got an antacid tablet. What is antacid? Which removes acidity. Where from the acidity comes? If you happen to start with this volumetric analysis, you will come up with the answer to many questions in chemistry which may be troubling you earlier on. Antacid है क्या चीज है आपको पता लगेगा. You will come to know. Antacid क्या होता है? Acidity of stomach, indigestion. Why we get the indigestion? So if you keep on turning back your screw and why is ultimately you will come to, there are so many unanswered questions and you will be able to answer that if you keep on going into the details of that. Acid produce क्यों होता है? Why? Can you think of? Body में, stomach में acid produce क्यों होता है? Digest food. What part of the food is digested? Which part? There are several parts of the food. Proteins है, carbohydrates है, glycerides है, oil है, fats है, बहुत कुछ है. किसको करना? प्रोटीन को. प्रोटीन को तोड़ना है, छोटा करना है. लंबी प्रोटीन होती है, long molecular mass. It has to be broken down. So you require an acid. So the body produces acid. कितना concentration होगा acid का? It's a very strong acid. Mind it. pH may be around 2 to 3. You are familiar with pH? 2-3 pH होगी approximate. कितने pH है body के अंदर? और acidity कैसे produce हो रही है कि जैसे ही आप चीज डालेंगे तो this will trigger up mechanism here and then it will release acid. And then acid, if there is some complication, hyperacidity comes, always producing acidity, and the stomach gets upset and everything. Now you have to have an antacid tablet. Antacid is, of course, anti-acid. So it destroys acidity. What is the type of the reaction you are getting involved into? Neutralization reaction. So neutralization reaction. So whatever you are taking the antacid, what that antacid should be in your opinion? It should be alkaline in nature. So what kind of alkalinity is there? It should be a strong base or a weak base. But our body may not be able to sustain a strong base because the other parts of the body may be affected by a strong base. You know that if you wash your hands with NaOH, what is going to happen? Blisters. So that's why a weak base is tried with washing soda Na2CO3. So these things have to be kept in mind. This will make you very inquisitive about what is happening. A small little problem in this volumetric analysis will lead to many more questions, and if you happen to go into it, if you get interested into it, you would be able to solve all these, and you will be becoming a very enlightened student of chemistry. That's what my aim is, to make you enlightened about the chemistry is everywhere. Right from the beginning, you get up from your bed, it is there. Your tears, your mouthwash, your brush, everything, the nylon brush. What is nylon? If you keep on thinking about those things. Now, antacid is just magnesium hydroxide and aluminum hydroxide. Magnesium hydroxide is a weak base. Aluminum hydroxide is a weak base. We don't want to trouble our, body system with a strong bases. Baking soda tak hum kha lete hain. Baking soda is a very weak base. pH approximately 7.5. Sodium carbonate we can't eat. It's used only for washing purposes, washing soda. And sodium hydroxide, caustic. It has a caustic effect on the skin. It's a very strong base. So That's why baking soda, we can put it in your cakes. We can put it in छोले बनाते हैं जो you must have seen kitchen में use हो जाता है. So you can eat sodium bicarbonate also, sodium hydrogen carbonate nowadays it is called. So to remove that extra acidity. So basically it's a neutralization reaction. How much is would be required for the hyperacidity? So you take few tablets and the rest of thing is washed away. The pH is to be maintained. Now in this case, what you are doing is you have to find out how much antacid would be effective for your stomach acid, or you can find out how much is its capacity to neutralize the acid. How do you find it out? You will devise it or volumetric analysis. We titrimetric analysis. You will take a standard solution. You know what is a standard solution? Standard solution is that solution whose concentration, whose molarity or normality. You familiar with now molarity and normality concept, I suppose, if you have done the mole concept. So then if the acid molarity solution is known to you, how much acid would be consumed for neutralizing the antacid tablet? Now you have to convert it into some solution form, that antacid, or you can put what is there. You can directly do the titration also. It will be converted, magnesium hydroxide, it will be converted into magnesium chloride, aluminum hydroxide can be converted into aluminum chloride. How much acid is consumed, you can find out, and you can find out how much is this effective antacid. Is a good antacid or a bad antacid, or it will destroy this much acidity or this much acidity. So these are different things. Now you come up with an example of fertilizer. How much nitrogen is there? You want to find it out because plants requires nitrogen. Now what are you going to do about it? You have to devise a method for that. Think about it. Let us say it is ammonium sulfate. Ammonium sulfate contains nitrogen and used as a fertilizer. Now you want to find out how much in a fertilizer may be a mixture of many things, and it may contain little of ammonium sulfate also plus some potassium, other species also have good fertilizer. But you want to find out how much nitrogen it will be able to transfer it to the plants. Now, what is the method you can think of? Ammonium sulfate, you devise a particular reaction. Oh, what should I do? Ammonium sulfate, it reacts with NaOH. So the reaction also come into your mind. You will find out the reaction with which it reacts. Ammonium sulfate reacts with NaOH to give you ammonia. And then ammonia gas is collected. Ammonia gas is collected, it's weak base. You can titrate it against a strong acid whose known concentration is there, molarity is known. You can find out how much ammonia is there, and from the back calculation you can find out how much is the nitrogen present in the original sample. See, whatever species ores ascorbic acid hai. Now you think about what is ascorbic acid? Vitamin C. Nowadays it's very popular. What is this ascorbic acid? Think about it. Which method you would try to employ? As the name suggests, is SID. So the type of the titration we would involve is neutralization reaction titration, and that is called, the name is acidimetry, alkalimetry, or whatever name you may call it. But you understand what I am saying now? Acidimetry, alkalimetry, you will think about, should I use a base? Yes. You can use your own method. You can make your own method to find out how much acid was there, and you can find out the ascorbic acid. Or now another property of ascorbic acid. So it depends upon the property of particular substance whose concentration is to be found out. That is the important aspect of it. Which method you are going to use? There are several types of titrations. There are titrations which involve acidimetry, alkalimetry, plus then you have redox titration. Redox means what? Redox, red, R-E-D-O-X, or O-X. You have a reducing agent, you have an oxidizing agent. So it's basically an oxidation reduction reaction. So oxidation reaction takes place only when there is a reduction reaction. Reduction reaction will only take place when oxidation is there. Half to hoga nahi kabhi reaction. Nahi. You have to be that way. You have to understand this thing. Redox reactions, there has to be an oxidation. There is now ascorbic acid is a reducing agent also. So you can use, think about it. You can use an oxidizing agent as a titrant. Titrant is the thing whose concentration is known to you, which you can use, and you can find out the amount of the ascorbic acid present. You've given an ore sample, copper hai, iron hai, manganese hai, anything, alloys hai. Alloys, you know that they are very useful. Alloy mein how much is this, how much is this, which alloy would be suitable for making the railway bridges, railway trains, coaches, ships. All these are very important aspect. In all laboratories, nowadays sophisticated methods are there, instrumentation, which will be very accurate. But the only thing is that the black box would be accurate only if it is handled properly and a maintenance is done. Otherwise, it's going to give you in your figures 1.2, जैसे digital clock होती है 1.0 बता दिया. अब माने ना माने, अंदर क्या चल रहा है उसके ये तो पता नहीं, because it's an electronic system. Electronic system is governed by what? It is governed by a particular property of that particular substance which you are using as a spaces. उसकी कोई property होगी जिसको वो आगे reflect करता है in potential को आगे reflect करता है, वो digit आगे दिखा देता है. So that way instruments are good, but the only thing in that when they becomes bad, it is a troublesome thing, and it requires a mechanic, and no ordinary person of your laboratory or a student would be able to handle. Whereas a burette is a very simple cylindrical apparatus, is a stopcock there. Stopcock टूट भी जाता है तो एक दूसरा glass blower आता है, वो उसको glass blower को लगा के, very simple to handle, accurate, very you can say versatile. Versatile जानते हैं ना? Versatility is that you can use it anywhere easily for every type of reaction. If you want to perform a redox reaction, you can do it with the same burette, same pipette, and same conical flask. If you want to do a precipitation titration, again you can use that. You want to use a complexometric titration. As the name suggests, there are several types of titration you may think of, and they are all very useful for analysis. And without analysis, hardly any research would proceed further. I must tell you that analysis is of a very great consequence, because without analysis, you may not be able to decide what should I do further on. Every stage of a reaction has to be analyzed. इतना बन गया, इतना बन गया, इतना बन गया. कौन से principles involved होते हैं इसमें? In this analysis, you would be learning about many principles. In fact, all principles, whatever you have read in your chemistry classes, would be used. It's an applied branch. All application oriented. You will be using all this. What are you using for a neutralization reaction? Let us say HCl plus NaOH. What does it give you? NaCl plus water. Very good. Now, what is HCl? It's a strong acid, or what is the meaning of the strong acid? Which dissociates almost completely to give you a hydrogen ion. So there is no, the reaction direction is one way. It dissociates almost completely to give you hydrogen ion and chloride. NaOH, it will give you Na plus and OH minus. What is the net reaction in a neutralization? It's a net reaction is hydrogen ion plus hydroxyl ion gives you water. Why does it give you water? The reaction direction is where? It's an equilibrium. H plus OH minus. I'll just Now I put this the equilibrium. Now law of chemical equilibrium comes into place. So you ought to know about what is equilibrium, chemical equilibrium, how does it change, what is it? You may say it H plus or H3O plus. Technically nowadays we write this thing H2O. Hydronium ions. It's of no consequence actually. But why does this reaction take place? If you keep on thinking about a particular reaction, you might, you will you'll start all your whatever you will learn, you will come to know that why this reaction has to take place. Equilibrium is there, but why? Why two water molecules would join together to give you hydrogen ion and how much hydrogen and hydronium ion and hydroxyl ion would be produced? What is the amount of this 10 raised to power minus 7? So it dissociates to a very small extent. Water does not conduct electricity. Do you understand? Why does it not conduct electricity? Because it ionizes to a very little extent. How much does it ionize? 10 raised to power minus 7, 10 raised to power minus 6 gram ion per liter. Now, they almost negligible. And this concept has been used to find out the pH. How much is the concentration? 10 raised to power minus 7. Minus 7. Both are equal because, stoichiometrically. Now, in this case, the total is 10 raised to power minus 14. What is that called? If your K value is H3. Now this H2O remains a constant because it's in excess. So it becomes, if you take it here, it becomes Kw, ionic product of water. So this becomes 10 raised to power minus 7. How much is the value which has been found out? 1 into 10 raised to power minus 14 at 25 degrees. Now this is very important. The temperature changes. What would happen to the ionization? As the temperature changes, what would happen to the ionization? Does it increase? Does it decrease? And what would happen to the Kw value? Is it a constant? It is a temperature dependent. Equilibrium constant is always temperature dependent. So different temperatures, you have different values of Kw. I will give you the values if you want it. So you will find it out. I'll just give you a brief idea about this. Not a very 0 degrees Celsius, 0.2 into 10 raised to power minus 40. And 20 degrees, 0.68. 25 degrees, 1.01 into 10 raised to power minus 40. 30 degree, 1.47. So this is the concept which we use for pH. That's 25 degrees. Otherwise, what would happen to ionization would increase. Why does it increase with temperature? Why does it increase with the temperature? More interactions. So the more hydrogen ions breaking and more pulling, more pressure. So the number of the hydrogen ions increase, right? So in this case, the 1.01 we are taking into, and pH is a concept you are familiar with now, or yes or no? What is it? pH is equal to I'll be talking about the concepts only. See, if you have some specific question, if you want me to do certain other things, I'll do that. But if you are good at concepts, you will not fail in your exams, or you can use your brains later on. But pH is minus log of 10 hydrogen ion concentration. What is the concentration units? Mole per liter, you could say gram equivalent per liter, depending upon the basicity, how much is the basicity of the acid. So hydrogen ion concentration, you log to the base 10. Now, in this case, this square bracket, it always means equilibrium molar concentrations. Now, this you may be written as H3O plus also, it does not make much of a difference. H to power minus साइमन लगाएंगे तो pH कितना हो जाएगा neutral water का? What would be the pH of the neutral water? 7. Now, this pH concept is to be used in your acid-base titrations. What is the underlying principle? How do we use a particular, devise a method to determine the amount of an acid substance or basic substance by using acid? Or if you have an acidic substance whose concentration is to be found out, you can use a base. So you would make a standard solution of an acid or standard solution of base depending upon whose concentration is to be found out. And then the titration, and then you will come to know about using this pH concept, the hydrogen ion concentration. The net reaction is this in all acid-base reactions. If you have more concentration of hydrogen ion than 10 raised to power minus 7, more means what? 10 raised to power minus 6. Okay? More in the negative sense would be 10 raised to power minus 6, so pH would be 6. If you have less than 10 raised to power minus, then would be 8. You are familiar with this, I suppose. Is it okay? Am I making it clear, or you have some queries? Now, in this acid-base titration, if we can see quickly go through these. Now, this is the method of chemical analysis. Amount of substance, determine the measurement of the volume of that substance. Okay. Determine the unknown concentration of a reactant. Volumetric analysis is often referred to as a titration laboratory technique. One substance of known concentration and volume is used to react with another substance of unknown concentration. Now, there has to be a reaction between the two. This reaction has to be seen what type of a reaction it is. You have to find it out. Next is involves the preparation, storage, measurement of volume of chemicals for analysis, volumetric, tetrametric, quantitative chemical analysis, which determine volume of solution accurately, known concentration required to react quantitatively. Now the word quantitatively. इसके लिए कितना exact amount लगेगा with analyte whose concentration is to be. What exactly we will find it out is the volume. So that's why the name volumetric analysis. The volume of the titrant required to just completely react with the analyte is the titer. Now the only thing next, titration, a process in which a standard reagent is added to a solution of analyte until the reaction between the two is complete. Primary standard. A reagent solution of accurately known concentration is called a standard solution. You can make your own standard solution. By taking that particular substance, weigh it, and putting it in a definite amount of water and 100 ml, 250 ml, so that it's manageable. Because we do not talk in liter. Liter में तो मुश्किल हो जाता है. Laboratory में छोटे level पे deal करते हैं. That's why we do not talk of moles. Moles की बात करते हैं हम लोग, नहीं ज़्यादा करते. Volumetric analysis में we do not talk of moles. मोल में ज्यादा हो जाता है. क्यों? मोलैरिटी में क्या है? व्हाट इज मोलैरिटी कांसेप्ट? Number of moles per liter of its solution. Now per liter is a student cannot handle it. You can't take a 1 liter of the solution and keep on the titration. What do? We generally take 10 ml or 20 milliliter. That is the maximum. to manageable limits to make it in the laboratory, and don't waste our solutions to such an extent that we are going to throw it out and make more environmental hazards outside. Now, this is okay. So we talk of, instead of moles, we talk of millimoles now. Instead of talking about equivalents, we'll talk about milli-equivalents. Because if you change the volume from liters to milliliters, it becomes millimoles and milli-equivalents. So most of your calculation in the volumetric analysis would be having, talking about millimoles, milli-equivalents in milliliters, not in liters or something like that. Because it's easier to handle smaller volumes, right? Next. Next, please. Definition of, now, how do we know the reaction is complete? The NaOH plus HCl is there. How do we know? Because both of them colorless solution. There must be some change at the equivalence point when exactly NaOH is equivalent to HCl. With our eyes we can't see. With any other, we have to use some technique. And what that technique should be, depending upon what exactly would be the concentrations or what happens at the end of this titration, completion of the titration. उस टाइम पे क्या हो गया, क्या बन गया? पहले क्या था HCl? Let us start with this. We have taken HCl or NaOH or whatever it is, NaOH in the conical flask. 10 ml पिपेट से लिया, सक किया, डाल दिया, ऊपर से ब्यूरेट चलाया, उसमें HCl of a known concentration is there. Now you add, keep on adding HCl. Both are colorless solution. You will not come to know when to stop. कि NaCl बन तो रहा है, but you can't check it because HCl ज़्यादा है या NaOH ज़्यादा है या NaCl बना है कि नहीं बना, कितना बना है पता नहीं लगेगा. So how do you do it? You have to devise a method. What is the method? Method is by using an indicator. Indicate, which indicates that now this is the end of the titration. This is now equivalent. The point at which the reaction is observed to be completed is the end point. The end point in the volumetric and method of analysis, the signal देता है, बंद कर दो अब titration और नहीं डालना. No more addition of HCl. Tells the analyte to stop adding and make the final reading on the bullet. Now start कहाँ से किया था और end कहाँ से किया था. The difference is your volume. Always do not take that reading as the milliliters. Readings तो किसी में बड़ी ऊपर होगी, किसी में नीचे होगा. Readings, the difference is the whatever is the volume you have used of the HCl for titration. Equivalent point. What is the difference between end point and equivalent point? The point at which the equivalent or stoichiometric amount of titrating added to the analyte based on the stoichiometric equation. Now, let us take this NaOH plus HCl. Simple example. NaOH plus HCl will give you NaCl, right? 1 molar NaOH है, 1 molar HCl है, इसका 10 मिलीलीटर लगा है, इसका कितना लगेगा? Volume. Exact stoichiometry. 1 mole of NaOH, 1 mole of HCl. When we have added exactly 1 mole of NaOH to 1 mole of HCl, this is the exact point, equivalent point. Now it is equivalent. Is it right? How much it would be required? Can you think of any small little calculations? Volumetric calculations involve nothing but M1, V1, M2, V2. You can take this as HCl. You can put it in the bracket HCl, ऐसे डाल दे, इसको NaOH डाल दे. ये पता है 1 मोलर है, ये पता है 1 मोलर है, ये पता है 10 water and ये. Exactly. Whenever you have added exactly 10 ml, exact 10 ml, this is your equivalent point. But this is very difficult to detect. What is the method you are going to use? At this stage, neither hydrogen ions are there nor hydroxyl ion there. कितना होगा hydrogen ion at this stage? What should be the pH of the solution when you have added exactly the 10 ml? pH कितना होगा? Can you think of? What should be the pH of the solution when you have added exactly 10 milliliter equivalent? 7. Good. Because it will be only salt and water, NaCl and water. Water again dissociates to give you 10 raised to power minus 7 and the pH would be 7. Is it true for every cases? No. This is true for every cases? No. We have to, improvise as we move on. Now, if I take ammonium hydroxide, what is the ammonium hydroxide? Right? Now, what is the situation like now? It's a strong acid. This is a weak base. Ammonia solution in water is called ammonium hydroxide. Technically, it's not, but it's the ammonia solution. But this is a weak base. Now, what is going to happen? What should be the pH of the solution at the exact equivalent point? I just want you to think about it and give me a correct answer, because I consider it to be more of an interactive session. 7, less than 7, greater than 7.
Less than 10.
All of you agree to one thing, that it is less than 7. Why? Strong acid. So? So you go to form this ammonium hydroxide, ammonium chloride, right? Ammonium chloride is the ultimate product, which is salt and water. What is ammonium chloride? It's an acidic salt. We call it acid salts. Because if I take ammonium chloride and put it in water, what should be the pH? It will give you HCl and ammonium hydroxide. HCl being strong, ammonium hydroxide being weak, less than 7. So you can make it the other way around also. You can use it. So you can think about it, keep on thinking most of the reaction, find out what is an acid salt, what type of an acid salts are there, what should be the pH. pH is the main important factor in all acid-based titrations. And we use this pH only to detect the endpoint also. हमें endpoint detect करना है. Now, the equivalent point is X point and endpoint. What is the difference? If I add 1 drop extra of HCl, 1 drop extra or a small half a drop extra of HCl in the NaOH solution, then what happens? Equivalence has been achieved. That was extra hydrogen ion, or if I take a sodium hydroxide in the burette, then hydroxyl ion would be there. What should be the pH? You can calculate it easily. I'll give you the calculation methods also. This is in your NCERT book also, maybe in acid-based titrations. So you will find it out that what really happens. This is your burette and these are the apparatus. This part is over. Have you understood? ये पिपेट है वो जो येलो, हाँ, और ये फनल है, ये वॉश बॉटल है. This is the conical flask. So if you do the experiment, you will enjoy, in fact, doing it. Now, what we were discussing about the pH concept. pH, one drop extra. Now, again, it is a colorless solution. If nothing is visible to your eyes, so you'll have to have a indicator. Indicator means what? Visual indicator. There can be several types of indicator. Potentiometric titration may not be involving any indicator. Instrument does the job. But if you want to do the job, then your eyes have to do the job. Change in color. That is what we say. So if I put an indicator into it, a small amount of that particular sum, what should be that indicator? What should be the properties of that indicator? What should be the criteria for using a particular indicator for a particular titration? That you have to decide according to your chemistry principles involved in it. Now, then theory of indicators is Oswald's theory. We'll have to understand that. Now, one drop extra means certain ions are extra. And that extra ions react with that indicator and change its color. So whatever we observe in any of your titration is actually the end point, which is 1 or half a drop extra from the equivalence point. So you have to either make a correction for that in your final calculations or whatever, right? Next. Equipment is okay. Two solutions are used. Write a balanced equation. Now, this is the most important aspect of it. Balanced equation. Why do we insist on a balanced equation? Because M1 V1 is equal to M2 V2 is not going to be applicable for everything. You need a balanced equation. Now, you have a barium hydroxide. What is barium hydroxide? A base, and you have to right. Now, base, now this is 2. For 1 mole of this, you require 2 moles of HCl. So what do we say? Barium hydroxide, the acidity of barium hydroxide is 2. Similarly, if you have H2SO4, what is the difference between H2SO4 and HCl? It's a di-basic acid. It will give you 1 mole of sulfuric acid, H2SO4 will give you 2 moles of hydrogen ions. Right? It's not necessary that you have to have a base as a hydroxide also, because basic substances can be many, and you have to manipulate the things. And for example, one of the major titration which you do in your is sodium carbonate. What is this sodium carbonate? Washing soda. It's a base. How do we know it is a base? It does not give you hydroxyl ions. What is the definition of a base? It does not fall into that category of supplying you with the hydroxyl ions. Though it does it, but only thing is, later on I'll tell you. It is a base because it requires 2 moles of HCl for neutralization. So what is the nature of it is, how it is different from ammonium hydroxide or other things? Because it requires 2 moles. So it is a di-acid base. So a factor which is in acid-base titration, in a factor which is N comes into play, which talks about how much is the requirement according to a balanced equation, N factor. So in order to this equation to be applicable, what we have to do is multiply it by this N factor, right? समझ में आया? सल्फ्यूरिक एसिड है, अगर ये एसिड है, सल्फ्यूरिक एसिड लेते हैं तो कितना हो जाएगा 2 here, और NaOH है तो ठीक. Now it is okay. So N factor comes, this N factor comes, keeps on cropping up everywhere in redox reactions, but not in complexometry. I'll tell you why also later on. This part is okay.
Yes, sir.
Now, if you have any questions right now, you can ask me because I'll be continuing with this. Now, what really happens when you perform the titration? We can continue for this quickly. The burette is attached to a clamp stand above this. This is your flask where you make your standard solution by weighing and putting into that with the help of a funnel, and then dissolving it in a fixed quantity of water so that you know its concentration. ये दो yellow है, this one. From this you can use this solution. This is a flask, long bottom. There is a marking there. It indicates 500 ml. Now, this you can see it easily. You can fill up with the help of a pipette. Pipette is, these are to be calibrated. Calibration, because they are at 25 degrees Celsius, and if you're performing the titration, the calibration has already been done. But only thing is that if this 10 ml is really 10 ml or not, because the glass also expands under temperature. But we normally use Corning glasses which have a little coefficient of expansion. So that way we can take care of it. Or if we are more accurate about it, we'll include the correction factor into it. So you suck out certain amount and then put it here and start doing this and use an indicator which tells you when to stop the titration. This is enough. After that, it should be reproducible also. Means if I take another 10 ml of it and wash this and the second conical flask, the value should come out with the same, if you are doing it correctly. Normally the students do not do it correctly, so you'll ask them to perform the titration 4 or 5 times and find it out if 3 of them are exactly the same reading, concordant readings. So the concept of concordant reading comes. So because initial reading, there might be mistake, 1 extra drop, 2 extra drops. How do you check the endpoint? Whether the endpoint is there. Suppose I add phenolphthalein and you have a HCl solution. Phenolphthalein gives in acidic medium is colorless. When you add NaOH solution from the burette, when the equivalent amount has been added, nothing happens. When 1 drop extra is added, it makes it pink because there are extra hydroxyl. And phenolphthalein in the presence of slight alkaline medium will change its color. Because its structure is like this, its structure changes into benzenoid or quinonoid structure. Quinonoid structures are colored. So quinonoid structure, the phenolphthalein is phenol and phthalic acid. Combination of this phenolphthalein is an indicator. 1% is used, small amount is used. And when extra hydroxyl ion is there, that is pH is around 9 or something, 9.3. It will change it to pink. When you make it, add a little acid from outside, extra acid from it, becomes colorless. So it should be this way and that way also. You can check with 1 drop, the pink color should disappear. With 1 drop from the burette, the color should appear. So that is the exactly how to check the endpoint in actually when you are doing it. Checking is very important because otherwise you will, pink to aata hi jayega. If you keep on adding more and more of it, pink to rahega. But people would say pink to aa gaya sir. आया नहीं. एरर है उसमें क्योंकि आप एक्स्ट्रा डाल दिया है. एक्स्ट्रा नहीं डालना होगा. एग्जैक्ट इक्विवेलेंट से 1 ड्रॉप एक्स्ट्रा. दैट्स ऑल. नेक्स्ट. Read the initial level of the liquid in the burette, turn the tap to start pouring out the liquid in the burette, swirl the flask. Flask को swirl करना जरूरी because the reaction is taking place. What type of reaction? Neutralization reaction. When the color changes permanently, stop the flow and read the volume. Volume change needs to be calculated and written down. This is called the titer. Repeat the titration with new flask now that you know the rough volume required. Repeat until you get precise results. Initially गलती हो जाती है, तो first reading rough reading हो गया, उसके बाद next exact. Now you know 9.5 पे आ रहा था पहला, तो 9 के बाद be careful, एक एक ड्रॉप डालिए, सॉल्व करिए, चेक करिए, कलर आएगा. ठीक है, next. Types of volumetric analysis. Now we venture into this. Now acid-base titration, precipitation titration, complexometric, redox, oxidation, reduction, oxidation is redox. These are the 4 types. Of course, there are several other types also. Potentiometric titration, coulometric titration, depending upon the change in the potential current. You can devise different methods where instruments are also used. But for your simple things, these are the 4 sets of types of titration which may be sufficient, which may include other also subheadings. Next. This is all right. बुलेट को क्लैम्प से किया हुआ है, सॉल्यूशन ऑफ द एनालाइट, मैग्नेटिक स्टरर भी डाल देते हैं कभी कभी, अगर हाथ से हिलाने में दिक्कत आ रही हो. वैसे तो होता नहीं है, फॉर सर्टेन it has to be constantly stored, then you may not be able to do it while doing the titration. So you would magnet piece डाल देते हैं, नीचे मैग्नेटिक्स वो है, करंट जाता है तो मैग्नेट बनता है, तो swirl करता रहता है. What is the idea of it? Nothing. Just to so that the reaction is complete. The reaction is complete क्यों होता है, उसको टाइम लगता है. These ionic reactions are supposed to be very fast. कितनी जल्दी होते हैं, कितने kinetics, reaction kinetics में the reactions, ionic reactions are the fastest. Over in a fraction of a second, you would take potassium chloride and put silver nitrate solution, immediately you start seeing the precipitates. Organic reaction थोड़ा time लेते हैं. Organic reactions, the kinetic factor is there. The carbon-carbon bond has to be broken. दिक्कत होती है. Next, sir. Acid-base reaction. Equivalence point, the point both acid-base have been consumed equivalent or exactly stoichiometric amount. Neither acid nor base is present in excess. Endpoint, actual indicator changes, because for indicator to change its color, you need an extra thing. Otherwise, indicator also remains silently spectator. Titrant, in known solution or added to the solution of unknown concentration. Titration curves, the plot of pH versus volume. Next. The point at which the reaction is observed to be completed. These are the 2 differences between the selective. What is endpoint and equivalent point? You are familiar with that. Next. But it's not a necessary thing that the reagent titrant has to be taken in the burette. You can do always reverse it. You can manipulate the titrations. Next. What happened during the titration? Acid, midway through the titration, and endpoint signal by the indicator. कुछ समझ में आया? है कुछ क्लियर हुए? ऊपर से डालते गए, V initial, V final, half पे डाला. अब as we reach near the end point, the reaction is about to complete. Slow down हो जाता है, तो swirl करना जरूरी होता है. तो increase the rate of the reaction. थोड़ा सा अच्छे से swirl करें so that exactly हो जाए. Because शुरू में तो आयन ज्यादा होते हैं, एक के ज्यादा होते हैं, एक के कम होते हैं. The equilibrium is always on this side. The forward direction reaction takes place. So the ions react in that particular way. This is all stopcock. You can open it. Idea is that you do it with the, this left hand and open it, and with the right hand swirl it. If you are the other way around, then you do the lefty हो तो फिर उल्टा है. ठीक है, और swirl करते रहना है. Next. अब रिएक्शन ऐसा चूज करना चाहिए, स्टोइचियोमेट्रिक होना चाहिए, नॉन स्टोइचियोमेट्रिक कंपाउंड नहीं बनना चाहिए. देयर आर नॉन स्टोइचियोमेट्रिक कंपाउंड्स, यू मस्ट बी फेमिलियर, जिसमें स्टोइचियोमेट्री फिक्स ही नहीं होती. They are all non-stoichiometric compounds. अब उसका कौन से non-stoichiometric compound? Are you familiar with the non-stoichiometric compounds? नहीं. जिसमें अब जैसे जितने ये है आपके कंपाउंड्स बनते हैं आयरन वगैरह के, उसमें कार्बन की परसेंटेज 0.2 है, 0.3 है, डिपेंडिंग अपॉन द टाइप ऑफ द रिएक्शन. Some of the carbon is there, sometimes it is not there. These are called non-stoichiometric. Graphitic compounds are there. They are non-stoichiometric. Means stoichiometric fix नहीं है. 1.3 भी आ जाता है, जैसे आता है ना, जो whole number आते हैं ना, ये वाला नहीं होता है. Reaction should be rapid, fast होने चाहिए. ये तभी titration कर पाओगे. अगर if it takes hours to complete the reaction, you won't be able to do the titration. Reaction should have no side reaction, no interference from other foreign substances. Other substances should not interfere into it, and no side reaction. कोई और side reaction चल पड़े साथ साथ, ये भी नहीं होना चाहिए. Must have some indication of the end of the reaction, such as color change. Now, these are the, how do we detect the end point? So some principle has to be there. What is the principle? Color change में sudden increase in pH हो. कुछ चेंज ऐसा होना चाहिए जो हम उसको यूज करके कोई और मेथड लगा सकें टू डिटेक्ट वेदर द रिएक्शन इज कंप्लीट और नॉट. दैट्स द आइडिया. जीरो कंडक्टिविटी खत्म हो गई एकदम, सडनली कंडक्टिविटी जीरो हो गई, देन वी कैन रियली फाइंड इट आउट बाय ए कंडक्टोमीटर, पोटेंशियोमीटर, और देयर आर डिफरेंट मेथड्स. सो सडन चेंजेस आर रिक्वायर्ड. पीएच में सडन चेंजेस आ गए. Another, in redox titration, you would come to know, redox titration में what is the principle involved? E0. E0 पढ़ा हुआ है आप लोगों ने. I'll be dealing more of this redox reactions later on. E0 values के changes हैं. E0 standard EMF values, standard redox potential values at a particular temperature is fixed. But now I'll just finish off the acid-base titration and then shift on to redox. Known relationship between end point and equivalent point. How much? 1 drop extra, half a drop extra. That next. Direct titration means direct. अब ये मैंने लिख तो दिया, बैक टाइट्रेशन था दूसरा. बैक टाइट्रेशन क्या है? अगर पर्टिकुलर जैसे है सैंपल है मेरे पास एसिड का, एस्कॉर्बिक एसिड का, उसमें मैं एक्स्ट्रा NaOH डाल दिया, उसको न्यूट्रलाइज कर दिया, जो बचा हुआ NaOH है उसको HCl से टाइट्रेट कर लिया. बैक टाइट्रेशन कर लो, कुछ कर लो. ये देयर आर सेवरल टेक्निक्स विच यू कैन यूज इट. डायरेक्ट तो सीधा दोनों का डायरेक्ट है, बट कुछ चीज एक्स्ट्रा डाल दी नॉन कॉन्सेंट्रेशन की, उसको रिएक्ट करवा दिया, और जो बाकी का बचा है उससे डिस्टिल करवा दिया. नेक्स्ट. This is one of the example calculation, or you can, this is hardly of any consequence, but you can use. But I will give you one method of calculation. I may not be doing all the calculations, but one method of calculation which you should learn it by heart and use it by all type of titrations, right? I have talked about M1 V1 is equal to M2 V2. What is the M1? Is the molarity. V1 is the volume. Generally, we use in volumetric analysis volume in milliliters. We do not talk in liters. That is the main difference. That's why we would be having a different types of numericals coming into it. When you talk of 25 ml of it, 24.3 ml of it, then the calculation becomes very little arbitrary. Firstly, you have to convert it into liters, or then to this or to this, whether this is to be used or N1 V1. What is the relation between the normality and the molarity? You are familiar with it. What is normality? What is molarity? There are two concepts which are prevalent in your volumetric analysis. Molarity is nothing but, I'll just, because this would require a little, if you understand this, then I should not be doing any numericals, and you would be doing the numericals easily. Whatever numericals which you may encounter, capital M is molarity. You have already read about molarity. It's number of moles per liter of what? May I ask you? Of its own solution. Right? This is your molarity. Now it is in 1 liter. And what is the molarity amount निकालना होगा, तो molarity कहाँ से आते हैं, number of moles कहाँ से निकालते हैं? Mass over molar. Very good. Molar mass. Molar mass. This is M. Now, number of moles in 1 liter, we do not talk number of moles in 1 liter because 1 liter is too big. As I've told you in volumetric analysis, we'll be talking about milliliter. So millimoles. Millimoles कितने हो गए? अगर 5 moles हैं तो कितना हो जाएगा millimoles? 5 into 10 raised to power 3. ठीक है ना? You can do that. Millimoles को लिखना ऐसे होता है. Millimoles, right? Now, in volumetric, you continue using M1 V1 is equal to M2 V2. Continue using this thing. Why I am doing it? It's just out of necessity because it creates quite a confusion in the minds of people whether normality is to be used or molarity is to be used, or sometimes it creates a lot of confusion. It's a redox titration or a acid-base titration. Then there's the N factor. You are familiar to some extent. What is this N? N means nothing but, you remember N. What is this N is? N for a reaction is, you write down an equation, a reaction, balance that reaction. You know how to balance the reactions? Even the redox reaction, oxidation reduction reaction by the oxidation number method, right? You're familiar with it or not? There are two methods, of course, oxidation number method or, so we'll do one or two and then we'll come to know. Let us take this MnO4 minus ion. This is a redox reaction I'm talking of. It gives you product Mn2 plus, right? This reaction is taking place in acidic medium. I'm not talking about acid base now. I'm talking to shift it to redox reactions, because acid base probably have already dealt with it here, but it is continuing with that. In the acidic solution, permanganate ion, which is a purple colored solution, very strongly purple colored solution, is a powerful oxidizing agent. Is used in redox titrations quite a lot. It gets converted into this. The E0 values for this is for half cell is plus 1.51 volt at 20. E0 means standard redox potential at 25 degrees Celsius when the concentration of the species is 1 molar in each case. That is the idea. E0. What is the difference between E0 and E is? E is the actual potential. When you're doing the experiment, the actual potential may not be 1 M, may not be temperature. So then the values change. So E0 is a constant. This is for comparison's sake. Now the next is, it oxidizes ferrous ion to ferric ion. There are two ways to balance this equation. The idea is that permanganate ion, if you have an iron sample, You have dissolved it into sulfuric acid and parasulfate, you have made it, and you want to find out how much iron is present. You will titrate it with permanganate solution. I'll tell you the details also later on. But firstly, try to do the calculation part, which always confuses the students. So either half reactions you can balance, or you can balance it similarly in the one shot also. Suppose the reaction is the reactants, I'll put it here, and the reactant here, the products here, sorry, right? Now from this to this, how much is the change in the oxidation state? Manganese is plus 7. It's a negative charge here. Plus 7. You can do it or not? Plus 7. It is 2 positive. See, in the elemental state it is 0. So you should be familiar with the rules of calculation of the oxidation number and oxidation states. This is your first. It is given you in NCERT books. Do you have to do it, or you will familiarize it and use it here? The change is of how many units? 5. Okay. How much is the change here, you would say? Whenever from higher oxidation state to a lower oxidation state, what is the type of a species it is? It's an oxidizing agent. And it is getting reduced to this. This is a reducing agent and it is oxidized to ferric. What is the change in the plus 2 to plus 3? 1 unit. 5 units. So this is the normal method of balancing the reaction. So you cross multiply it, right? It becomes okay. 1 here, here and here, 5 here and here, cross. So what does it show? 1 mole of permanganate ion will oxidize 5 moles of ferrous ions to 5 moles of ferric ion, and itself get reduced to 1 mole of Mn2 plus. So this is the net reaction. And to balance finally the charges, what you have to do, oxygens here, 4 oxygens are there in acidic medium, you put 4 water molecules to balance. 4 oxygens are extra here, manganese is balanced, iron is balanced, 4 water, and then since now 8 hydrogens are extra, it's an acidic solution, you put, okay, hydrogen ions. And now you balance it and you will find that probably all the charges and all the atoms are balanced. Charges, everything is balanced. It's a balanced redox reaction. Now, first thing for any numerical, if you want to attempt any numerical, what you have to do is, whether it is a volumetric analysis of redox reaction or anything, write down the balanced reaction. Whether it's a redox, then you have to use this method. If acid base is there, use other methods also. If it is an alkaline medium, you know about, then you have to introduce hydroxyl ions for balancing. Medium is acidic, so that's why I put hydrogen ions. But if the medium in which the reaction is taking place, redox reaction, is alkaline, then you have to balance it with hydroxyl ion and water combination. Now, this equation is written here, M2V2. This has to be modified. If both are same, 1, 1, reactants 1, 1, no problems. This M1 V1 is equal to M2 V2, right? But if it is not, then you have to be very careful. Then what you have to do is you put this Fe2 plus, both the reactants, because you are titrating this with this, two reactants are there. This is MnO4 minus I. Tick. Now, how many MnO4 are there? 1. 1. Divided it by 1. Divided by 1. That's all. Problem solved. Do it for every reaction. Do you understand? Once you do it, then this equation is perfectly okay. And you can, 3 things are known, 4 things can be calculated easily. For all redox, complexometric, or precipitation titration, or any other titration of any kind, you have to use a stoichiometric equation, and this is your equivalence. Equivalence is different from molarity. Now we are coming to the equivalent mass and molar mass. Molar mass और equivalent mass में फर्क क्या है? Molar mass divided by n factor. What is that n factor? It depends upon the, whether it's say dibasic acid or a tribasic acid or a diacid base or a triacid base, whatever it is. In redox titration, it is the number of electrons lost or gained. Different thing, and is a variable. And equivalent mass is not a constant for a particular substance. It can change. It changes with the type of the reaction which it is performing. You don't take it as a constant. Equivalent mass is not a constant. Molar mass is a constant.
Hello.
Okay. Yes. Haji?
How to find the pH of a solution numerically?
Numerically. All right. pH of any solution in the titration. All right, I'll do it. Do you want me to do it right now, or just finish it off and then? Oh, just let me finish off this particular heading and then I'll change it to the pH also. Okay. Now this part is okay. Do all the calculations in this particular way and you will not fail, because how much it is, irrespective of whatever is, balance it, divide this and use it without bothering. And millimoles का concept है, millimoles का concept है, milli equivalents का concept है, moles और equivalent में क्या relation है, molar mass by n है, equivalent mass है, n क्या है, ये सारी चीजें हैं. But normally you may not even find it necessary to do it. Equivalent mass अपने आप आ गया, equivalence आ गया, इसमें से ये equation में equivalence आ गया. So molarity you can find it out. Molarity you find it out. You can find out the number of grams. You can always keep on manipulating. ये reaction था, इतना use हो गया, इतना हो गया, minus plus. All these calculations you can do it. I'll do 1 or 2 numericals and you will come to know it's easier. You can take this for another example and then I'll shift to that particular answer. Now this dichromate ion, potassium dichromate, is another oxidizing agent which is used in the laboratory quite often. This is gets into chromium 3 plus, and this will also oxidize ferrous ions, and this is the reaction. Firstly, balancing. What is the idea? Dichromate ion, potassium dichromate. The effective part is the dichromate. That we do not talk of potassium ions even. Dichromate ion will oxidize ferrous ion to give you chromium 3 plus ion and itself, and ferric ions and itself get reduced to chromium 3 plus. And first thing is what? First thing is balance the chromium. There are 2 here, there is 1 here, 2. Now start the process of oxidation state. +6 for each chromium. For how much is there for 2? +12. This is it. Here +6 difference. How much is the difference? 6 plus 2 are there, 12. Here 6 plus, the difference is total difference you have to find out. Do you understand? Whatever it is, make it total. Change in the oxidation state total. Here 1. So multiply it by this. 6, 6 and 1, 1. Now the balance. Balance क्या करना है? 7 oxygen extra acidic medium में है. What should I put? 7 H2O and double the number of hydrogen, 14 H plus. Clear? Now M1V1 is equal to M2V2 करना वही कैसे? Dichromate का और ferrocyan का. So you take any redox equation which is slightly more confusing also in calculation, but use this method and you will not fail. That's my idea. It is given in your NCERT book also. But try to use it, because if you use some other books, it may somebody would be talking about the equivalent mass. First calculate the equivalent mass and then use it. First calculate the normality. You know, sometimes confusion, will delay the process of your numerical solving. That's it. Is it okay? So you take any equation, any equation, even an acid neutralization reaction, even a precipitation, balance it, balance it. This is my idea. Balance it. Use the molarity equation, but divide it by the number of moles of that particular substance, and then do the calculation. Clear? Now somebody wanted me to how to calculate the pH of numerically. एक मेरे पास वैसे तो था मेरे पास नेक्स्ट है कैलकुलेशन है कि नहीं उसमें, नहीं तो मैं इधर से देख के करा देता. आपके ये तो नहीं है एक्चुअली. व्हाट शी वांटेड इज प्रोबेबली how to calculate the pH. See, there are two things which you calculation acid base next. This is 1 mole of acid, half a mole base, but differently it has been done, but you use the same method which I have told you. Next, you find out the molarity, the same thing again. Okay, next. You can find out the molarity of NaOH. दूसरा method है ये. Second method use किया. You can use many methods, different types. This way you can, if you handle your nose, you can handle it like this, or you can handle it like this also. It's always here. Next. Why direct reaction is not sometimes used? Because directly थोड़ा slow है, तो back titration करनी पड़ती है. No suitable indicator interfere करता है. The color change is slow or delayed. The end point is far from the equivalence point. बहुत ज़्यादा volume लगता है, तो error आ जाती है. अगर end point और equivalence point में difference ज़्यादा हो जाएगा तो क्या होगा? Error आएगा. Next. Back titration, simple acid base, greater the amount. Now, एस्टर जो बनता है आपने पढ़ा होगा, ग्लिसराइड्स वगैरह जो होते हैं प्लांट के, ऑयल्स फैट्स है, एस्टर्स है. यू आर फेमिलियर? ऑयल्स फैट्स के हैं, एस्टर्स जानते हैं ना. ग्लिसरॉल के OH ग्रुप्स और एसिडिक ग्रुप्स है, और फैटी एसिड्स लगे हुए हैं प्लांट में. ओलिक एसिड है, स्टेरिक एसिड है, सो मेनी टाइप. तो इनको अगर एस्टर ग्रुप को तोड़ दिया जाए तो एसिड पार्ट बनता है और अल्कोहल पार्ट. एसिड तो बनता है, acid बनेगा तो you can find out how much acid you have produced, how much was the ester. See, acid बना, acid को neutralize किससे करा, base से कर दिया. So this is the method which is simple acid. A base reagent is added to a known quantity, greater the amount for the acid neutralization. उससे ज़्यादा डाल दिया, ज़्यादा डाल के base ester को hydrolyze भी करता है, और ज़्यादा डाल दिया, और उसके बाद जो बचा हुआ बेस था उसको टाइट्रेट कर लिया अगेंस्ट ए स्टैंडर्ड सॉल्यूशन ऑफ एसिड. दिस सिस्टम हैज गॉन फ्रॉम एसिड पास द इक्विवेलेंट पॉइंट टू ए बेसिक, एक्सेस बेस में चला गया, एंड बैक टू द इक्विवेलेंट पॉइंट अगेन. द फाइनल टाइट्रेशन इज कॉल्ड द बैक टाइट्रेशन. अब बैक हो गया, ज्यादा बेस डाल दिया, डायरेक्टली पॉसिबल नहीं है. अब मेरे पास जो टैबलेट आया है जैसे एंटासिड का, मैं क्या करूँ उसका मैं क्या करूँगा, वो तो सॉलिड टैबलेट है, तो उसके अंदर मैं HCl ज़्यादा डाल दिया, डिजोल्व भी होगा, क्लोराइड बन के सॉल्युबल भी हो गया, एक्स्ट्रा HCl है ना. जितना तो उसके लिए रिक्वायर्ड था वो अलग है, जितना बच गया वो मैंने बेस से टाइट्रेट कर लिया, तो बैक टाइट्रेशन हो गया. सो यू कैन डिवाइज योर ओन टेक्निक, बैक टाइट्रेशन, रिप्लेसमेंट टाइट्रेशन, सब्स्टिट्यूशन टाइट्रेशन, देयर आर वैरायटी ऑफ काइंड्स. नेक्स्ट एग्जांपल ऑफ insoluble acid, insoluble organic acid है, स्टेरिक एसिड है, हैवी जैसे सोप में जो पड़ता है स्टेरिक एसिड, ओलिक एसिड है. अब वो डायरेक्ट टाइट्रेशन तो उसकी होगी नहीं बेस के साथ, एसिड है, दैट इज एन एसिड, स्टेरिक एसिड इज एन एसिड, बट उसकी टाइट्रेशन तो नहीं हो पाएगी बिकॉज वो इनसॉल्युबल ही है पानी में. तो उसको पहले बेस से करके उसका सॉल्ट बना दिया, सोल्यूशन में आ गया, उसके बाद कर लिया. Are you following my point? So you have to devise different ways. And next, please. Calculation वही है, जितना बच गया, जितना हो गया, calculation use the same method. Right. Next. कैल्शियम कार्बोनेट है आपके पास, मार्बल का पीस आ गया, उसमें क्या करेंगे? What you have to do is extra एसिड डाल दें, कैल्शियम नाइट्रेट बन गया उसका, ठीक है, जितना उसके लिए रिक्वायर्ड था वो तो हो गया, बच गया, ठीक है ना. डू अंडरस्टैंड? सो इसे प्रैक्टिकल implications देखिए, because you can use it a simple cylindrical tube and a pipette and a rapid reaction, fast reaction, no maintenance, nothing, no cost factor. Wash it and just again use it again, take it to some place, use it in different places in the country or outside. Reproducibility, accuracy, everything with a small, without having to undergo, lots of cost factor is hardly anything. Next. Is it okay? You can do it yourself. You try to do as many numericals, making it the fundamental thing. कैल्शियम कार्बोनेट क्या है? H2CO3 क्या है? डाई है कि H2CO3? डाई बेसिक एसिड, ठीक है, 2 हाइड्रोजन आयन देगा, सिंपल है. जिसमें 2 हाइड्रोजन आयन यूज अप हो जाए वो डाई एसिड बेस हो गया. सोडियम कार्बोनेट में 2 HCl लगते हैं तो 2 डाई एसिड बेस है, वो डाई बेसिक एसिड है. Next. Donate hydroxide, it is just anyway. Bronze state, this is a normal definition. Next. Choosing a titrate. Weak acids ये वाले choose हो सकते हैं. Strong and weak is titrate. Next. So these are the different things. Titration of strong acid. This will come under the heading which we will. She wanted me to discuss. Titration of a strong acid with a strong base. Strong acid with a strong base. What would happen? What would be the titration shape of the titration curve? The shape of the titration curve I will show you next, please. And then this is pH neutral. This is okay. एसिडिक. नेक्स्ट. हालांकि ये मोलर कॉन्सेंट्रेशन इज नॉट एग्जैक्टली द वैल्यू, इट इज एक्टिविटी, एक्टिव मासेस है. स्ट्रॉन्ग एसिड विद स्ट्रॉन्ग बेस. See, this shape of the curve, this is very important. Now the milliliter, suppose this is the, you have taken 50 ml and this is 50. I'll give you the, because it's not mentioned the milliliters. Same molarity is there, but 50 ml is used. How, initially when you keep on adding base, what is the change in the pH? That's what she was asking. Start with this. You have taken an acid in the conical flask. It has some pH. pH कितना होगा acid का? Less than 7 होगा. Less than 7 में कितना होगा? अगर 1 molar का pH होगा, तो pH कितना होगा? 1 molar solution of an acid, what should be the pH? 0. Minus log of hydrogen ion concentration 1, log of 1 is 0. So pH is 0. Start with the 0. अगर मैं 0.1 molar लेता हूं, pH is equal to, this is 0. Technically it is 0, but actually theoretical calculation is there, because this hydrogen ion concentration is not actually the molar concentration, it's the activity. In chemical equilibrium also we use the term activity, not the molar concentration. थोड़ा दिक्कत है उसमें. Activity is not equal to, but in dilute solution we can take activity as the molar concentration. Otherwise in concentrated solutions you have to talk of another factor, activity coefficient. थोड़ा अलग है. अब pH इसमें कितना होगा? 1 point HCl का. अगर मैंने I have started by m/10 solution of HCl, I have taken 10 milliliter of it or 100 ml of it. What should be the pH of the solution? Minus log of, what is the hydrogen ion concentration? 0.1 is 1/10, so pH is equal to 1. ऐसे है ना, बड़े अच्छे सिंपल कैलकुलेशन है ये, कोई ज्यादा दिक्कत नहीं है. माइनस लॉग ऑफ 1/10, ठीक है. लॉग लेंगे इज इक्वल टू माइनस माइनस प्लस हो गया, कितना हो जाएगा? 1. pH 1 0.01 लिया, 2. सी लॉग है ना, तो 0.01 ले लिया. ठीक है. pH कितना होगा? एग्जैक्ट नहीं है वैसे 2. I can understand because this is a activity and various factors are there, but roughly around 2. ठीक है, आपकी कैलकुलेशन के लिए चल जाएगा. अब pH 1 से चला है या 2 से चला है, स्टार्ट इससे किया, यहाँ चलो मान लो pH 1 है 0.1. अब नाउ आई हैव एडेड NaOH solution to it. ठीक है, NaOH solution है. Suppose I have taken 100 ml of 1 molar solution of HCl, right? 100 ml, and in the conical flask, this is the situation. In the burette, I have taken NaOH, right? वन एम का लिया, या ये तो बाद में निकाल भी सकते हैं, पर अगर वॉल्यूम पता हो, 3 चीजें पता हो तो 4 चीजें निकल सकती, 4 चीजें निकल सकती है. ये स्टॉप कॉक है, इसमें आई हैव एडेड 50 ml of it. or 1 ml of it. So there will be a change in the concentration of hydrogen ions. So change in the concentration of hydrogen ion क्या होगा? कम हो जाएंगे, ज्यादा हो जाएंगे? Hydrogen ion. So what would happen to the pH? बढ़ेगी, कम होगी? उल्ट बढ़ेगी, ठीक है ना? pH बढ़ना शुरू हो जाती है. कितना बढ़ेगी? कैलकुलेट करना पड़ेगा. कैसे कैलकुलेट करेंगे? ये एक मेथड है, अगर आप देखना चाहें तो लिख लें. जैसे 0 ml NaOH ऐड किया, 1 m 0.1 m 0.01 m, ये एक सेट मैंने लिखा है. अगर आप इसको अंडरस्टैंड कर दिया तो इसका मतलब आपको पता लग जाएगा कि व्हाट इज रियली हैपनिंग. देन आई विल एक्सप्लेन दी. ये HCl है, ये सारे HCl है. ये 0 ml है इस टाइम पे. व्हाट शुड बी द pH ऑफ दिस? pH जो निकाली, अगर सिर्फ इसमें है तो इसमें 0 1 2, ठीक है. अगर मैंने इसमें 50 ml NaOH डाल दिया, सेम मोलैरिटी का 1 m का, ये व्हाट शुड बी दी हाइड्रोजन आयन कॉन्सेंट्रेशन? कितनी रह जाएगी? कैसे कैलकुलेट करें? सिंपल सा मेथड है कि टोटल वॉल्यूम कितना मेरा हो गया? 100 था, 100 NaOH था, इसमें 50 ml NaOH डल गया, 100 HCl था, टोटल 150 वॉल्यूम हो गया, ठीक है. और HCl कितना बच गया वॉल्यूम में? वॉल्यूम की टर्म्स में निकाल लिया, मोलैरिटी की टर्म्स में चेंज नहीं किया, वॉल्यूम की टर्म्स में चेंज कर लिया. अब कितना रह गया? 50 इंटू में या तो 1 m या 0.1 m या 0.01 इंटू 1 m. इस केस के लिए 50 by 150 0.1 m. इस केस के लिए pH कैलकुलेट कर ली. इसकी pH आती है 0.5 1.5 2.1. If I added 50 ml of it NaOH, आधा डाल दिया, 100 पे कंप्लीट होना है, 50% डाल दिया, pH कितनी बड़ी? फ्लैट पोर्शन आएगा. दिस इज द इंपॉर्टेंट पार्ट. इट इज एक्टिंग एज ए बफर. चेंज ही नहीं हो रहा pH. 50 डाल दिया, चेंज ही नहीं हो रहा. pH अब पहले 0 थी, अब 0.5 हो गया. इसमें 1 थी, 2 3 2.5 हो गया. 75 ml, चलो 90 ले लेते सीधा ही. 90 ml 1.3 2.3 3.3. ये एक्चुअल कैलकुलेशन है. कैसे की है? वही फॉर्मूला लगा के. कितना हो गया? 90 ml डाल दिया तो 190 हो गया ना, 10 by 190. बस वो कैलकुलेशन में आ गया, pH निकाल ली, लॉग ले लिया उसका, ठीक है. अब pH इतनी आ गई 3.3. अब 90 ml डल गया, यहाँ पे आ गया तकरीबन, pH बढ़ ही नहीं जाता. देन नेक्स्ट 99 ml 2.3 3.3 4.3. अब क्या हो जाएगा? 1 ml बच गया, बाकी 1 by 99 आ गया, तब भी नहीं हुआ है. यहां तक ही है अभी, ठीक है ना. 99.9 पे आ जाते हैं सीधा। एक्यूरेसी देखिए इसका, दैट्स व्हाट आई एम सेइंग दैट विद अ सिंपल apparatus the accuracy is this 99.9 mm, 3.3, 4.3, 5.3। इसमें थोड़ा सा बढ़ रहा है, मतलब क्योंकि ज्यादा का आ रहा है 5.3, बट इफ आई टेक 1 mm और n/10 का सोल्यूशन लेता हूँ, m/10 का 0.1 m इज m/10, तो इतना आ रहा है 4.3। 100 पे कितने हो गए? ठीक है, अब 0.1 ml पे जंप कितना मिला? 3.3 से 7, 1 ml। यू अंडरस्टैंड? ये ऐसे जंप आ गया, ये यहां पे आ गया, ठीक है। और 100.1 पे क्या करेंगे आप? 100.1 पे क्या सिचुएशन होगी? ये तो मेरा इक्विवेलेंस पॉइंट था, ये इक्विवेलेंस पॉइंट इज रिफ्लेक्टेड हियर एट द इन्फ्लेक्शन पॉइंट। इट्स अ स्टीप पोर्शन, स्टीप है, पीएच से जंप मार रहा है, विद वॉल्यूम चेंज ही नहीं हुआ, ठीक है ना। अब 100.1 ml NaOH डाल दिया 1 मोलर का, या जो भी डाला सेम मोल, तो क्या होगा? अब 0.1 तो हाइड्रोक्सल आयन फालतू आ गए, टोटल वॉल्यूम इतना हो गया। अब हाइड्रोक्सल आयन POH आ गया, और POH और pH मिलके 14 में से माइनस कर दिया तो pH आ जाएगी, ठीक है, समझ में आ गया। अब मेरे पास क्या है सिचुएशन? 0.1 हाइड्रोक्सल आयन में POH निकालना हूं, और POH कनेक्टेड है विद pH, नेगेटिव लॉगरिथम ऑफ हाइड्रोजन आयन कंसेंट्रेशन प्लस नेगेटिव लॉगरिथम ऑफ हाइड्रोक्सल आयन कंसेंट्रेशन इक्वल टू 14, ठीक है ना। POH निकल गया तो pH निकाल लिया बैक से, कितनी आती है pH इसकी? 10.7, 9.7, 8.7, समझ आ रही है। फिर उसके बाद जितना मर्जी डालते जाओ, थोड़ा 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 थोड़ा, ये यहां तक ये सिचुएशन है। फिर हाइड्रोक्सल आयन चलते गया, ये स्टीप पोर्शन आ गया, ठीक है। अब एडवांटेज क्या है? We know that the at equivalence point or nearby the equivalence point, the pH jumps. Change in the pH is very, very steep. So this is the property which you are going to use for suggesting, for finding out which is the suitable indicator for us. कौन सा इंडिकेटर है which will color change its color in the steep portion में? यहाँ पे कलर चेंज कर दे, इधर नहीं करे, इस pH पे नहीं करे, इस pH पे नहीं करे, इस pH पे करे, एरर मिनिमाइज हो गया, एरर मिनिमाइज हो गया। एक ड्रॉप से चेंज करेगा, एक ड्रॉप एक्स्ट्रा डाला नहीं, 0.1 ml डाला नहीं तो छू, और इंडिकेटर ने उसी टाइम चेंज कर दिया। सो यू हैव टू इंडिकेटर्स नाउ, एसिड बेस इंडिकेटर है, एक फिनोल्फथलीन है, एक है मिथाइल ऑरेंज, मिथाइल रेड भी है, देयर आर सेवरल इंडिकेटर्स। नाउ एक थोड़ा सा आइडिया यहाँ तक, ठीक है। Calculations part, I think that was the answer she wanted me to calculate the pH of. यहाँ तक देखिए स्टीप पोर्शन काफी है ना। अब थोड़ा आगे एक बार थोड़ा वीक का भी देख ले, फिर उसके बाद इंडिकेटर पे चलते हैं। नेक्स्ट, टाइट्रेशन ऑफ ए स्ट्रॉन्ग एसिड, ठीक है। ये इसने 25 से किया हुआ है, 100 से कर लो, जैसे मर्जी कर लो। तो नेक्स्ट, अब फिनोल्फथलीन, फिनोल्फथलीन कब चेंज करता है? कौन सा? ये किस रेंज में चेंज करता है? Phenolphthalein is a substance. What type of a substance it is? It's a pH sensitive substance. It changes its color according to the pH of the solution. Solution के अंदर जितनी actual pH होगी उसके हिसाब से change करेगा. ठीक है? What is the nature of this phenolphthalein? It's an organic compound. It's a weak acid. pH HIN. It's a weak acid. I will introduce it like HIN. It's a phenolphthalein. Weak organic acid है. एक ड्रॉप डालना होता है अल्कोहलिक सॉल्यूशन का. इसका कुछ कलर है, इसका कुछ कलर है. दो डिफरेंट कलर्स है. अनडिसोसिएटेड इंडिकेटर एंड डिसोसिएटेड. ठीक है? इंडिकेटर ए बी कर लो. बी टू फॉर्म्स ऑफ द इंडिकेटर विच इज पीएच सेंसिटिव. एच पे ऊपर डिपेंड करता है, हाइड्रोजन आयन कॉन्सेंट्रेशन. ठीक है? अब इसका आप कैलकुलेशन कर लो, आपको पता लगेगा. जो है के ए जानते हैं ना, वीक ऑर्गेनिक एसिड है. के ए इज इक्वल टू ठीक है. इसको माइनस में कर लो और इधर कर लो. H प्लस में ये क्या होगा? उल्टा कर लो. ठीक है? ये हो गया पीएच हो गया, ये पीके प्लस ये वैल्यू. I just want to show you that they are all governed by the equilibrium constant pH. pH से dependent है. pK of the indicator. pK indicator इसको बोलते हैं. pK indicator क्या है? ये it will tell you, the pK value will tell you what is the range of the pH in which it changes its color. What is the color? Color is because of these two species. Which color we see? Which is more in concentration. अगर ये इसके 10 times हो जाएगा तो ये हो जाएगा log 10, 1 हो जाएगा. अगर ये 1/10 हो जाएगा तो माइनस. तो पीके वैल्यू जितनी भी आएगी ना आपकी, उसकी रेंज आती है प्लस माइनस 2 का यूनिट का. एक यूनिट इधर, एक यूनिट इधर. ठीक है? इस बीच में वो कलर दोनों का होता है. सो पीके वैल्यू ऑफ द इंडिकेटर इसकी कितनी है? पीके वैल्यू ऑफ द इंडिकेटर इसकी है कलरलेस फेनोल्फथलीन का बिलो 8.3 pH, कलर्ड पिंक कलर्ड. फेनोल्फथलीन में अगर NaOH डाल दें तो पिंक हो जाता है. pH ग्रेटर देन 10 पिंक आ जाएगा. ये रेंज आ गई. इसके बीच में क्या हो रहा है? थोड़ा पिंक, थोड़ा वाइट, कलरलेस, हल्का पिंक, बट 10 के बाद पक्का है. ये कहां से निकल के आई रेंज? इन दोनों की रेशो में. हमारी आइस को दो अगर कलर हो, क्योंकि मिथाइल ऑरेंज एक ऐसा इंडिकेटर है. अगेन मिथाइल ऑरेंज वीक ऑर्गेनिक बेस है. वीक ऑर्गेनिक बेस है. इसमें भी ये मिथाइल ऑरेंज जो है, मिथाइल ऑरेंज is another acid base indicator like phenolphthalein, but it changes its color in the range of 3.1 to 4.5. Below 3 point, it is red. Above 4.5, it is yellow. ये येलो रेड जो है कॉम्बिनेशन, अब मुझे येलो नजर आएगा कि रेड नजर आएगा, ये किसके ऊपर डिपेंड करता है? कॉन्सेंट्रेशन पे उसकी। ये जो मैंने ये बनाया, अगर ये इसकी 10 टाइम्स इससे ज्यादा है तो मुझे ये वाला कलर नजर आएगा, अगर ये 10 टाइम्स इससे ज्यादा है तो मुझे ये नजर आएगा। हमेशा ये होता है, आइज की एक लिमिटेशन होती है 10 टाइम्स, तो दैट्स व्हाई इट इज ए नैरो रेंज। सो दिस कॉल्ड द पीके वैल्यू, वी यूज दिस। अब मुझे ये बताइए, ये मेरी मिथाइल ऑरेंज की है, ये मेरी फिनोल्फथलीन की है, ठीक है? ये फिनोल्फथलीन की पीके वैल्यू थी, ये शो करता है कि ये इस रेंज में होगा ऐसा, और ये मेरी मिथाइल ऑरेंज है, एक अनदर इंडिकेटर विच इज ऑल्सो ए डाई, एजो डाई है। ये वाला आएगा, ये वाला यूज करूं कि ये वाला यूज करूं? कोई सा भी यूज करूं। क्यों? मेरे पास स्टीप पोर्शन बहुत है, मैं यहां यूज करूंगा तब भी 100 आना है, इधर वाला यूज करूंगा तब भी 100 आएगा। ठीक हो गया? क्लियर? नेक्स्ट, वीक एसिड विद स्ट्रॉन्ग बेस। अब थोड़ा वीक एसिड कौन सा लिया मैंने? वीक एसिड एसिटिक एसिड ले लिया, प्लस NaOH, CH3CONa, सोडियम एसीटेट बन गया और वाटर बन गया। pH कितनी होगी इसकी? At the equivalence point, what would be the pH? Look at pH कितना होगा? 7, 7 से कम, 7 से ज्यादा, 7 से ज्यादा। क्यों? It is a salt of a strong base and a weak acid ultimately, 7 से ज्यादा आएगी। अब मुझे कौन सा इंडिकेटर यूज करना है? ये दैट्स व्हाई इंडिकेटर मेरे को सोचना है क्या करूं, मैं कौन सा इंडिकेटर चूज करूं? इसमें स्ट्रॉन्ग बेस और वीक एसिड में which indicator is suitable for me? स्ट्रॉन्ग बेस, जबकि इक्विवेलेंस पॉइंट पे pH ग्रेटर देन 7 है, स्टीप पोर्शन कहां मिलेगा मुझे? ऑल राइट, आई स्टार्ट विद अगेन द बिगिनिंग। अब बिगिनिंग में चलो, आपके पास एक एसिड है, ये वीक एसिड है। वीक एसिड का मतलब क्या है? हाइड्रोजन आयन कम देता है, ठीक है? हाइड्रोजन आयन कम देते तो pH कितनी होगी? अब मैं कैलकुलेशन पार्ट पे नहीं जा रहा, क्योंकि इसमें वो डिसोसिएशन कांस्टेंट वगैरह भी आएंगे, बट ये तो बता दें कि pH इनके मुकाबले में HCl की pH जैसे आ रही थी या जिसकी आ रही थी उसके हिसाब से कितनी होनी चाहिए? 4 के आसपास होगी, 4, डिपेंडिंग अपॉन द एसिड कितना हाइड्रोजन आयन देता है, ठीक है ना? तो 4 से तो शुरू होगा मेरा ग्राफ। मेरा ग्राफ अब 4 से शुरू होगा, यहां नहीं शुरू होने का, यहां से होगा ऐसे। अब यहां तक पहुंचते पहुंचते न्यूट्रलाइजेशन पॉइंट तक वही 7 से ऊपर तक, तो ये पोर्शन मेरे को स्टीप मिल गया, ये वाला नहीं मिला। तो मुझे इंडिकेटर कौन सा सूट करता है? जो हायर pH पे अपना कलर चेंज करता है ना, phenolphthalein. So only phenolphthalein would be suitable because it changes its color within the 8.2, 8 to 9.3, 10. इस स्टीप पोर्शन जहां है उसी में ही मिलेगा। समझ में आ गया? क्योंकि स्टीप पोर्शन का मीनिंग क्या है? स्टीप पोर्शन का मीनिंग है मिनिमम एरर। एक पॉइंट, एक ड्रॉप से इतना जंप मिल रहा है, तो एरर मिनिमाइज हो गई। मुझे इंडिकेटर ऐसा चाहिए जो मेरी एरर ऑलमोस्ट नेग्लिजिबल कर दे। अंडरस्टैंड? बिल्कुल। जितना ये मेरे ख्याल में ये वीक एसिड वर्सेस स्ट्रॉन्ग बेस लिखा है, पर ये कैलकुलेशन जो है ना यहाँ से यहाँ पे इतना है, ये पोर्शन है, ये इतना आना चाहिए। नेक्स्ट में देख लेंगे थोड़ा सा, नेक्स्ट चलाएं। स्ट्रॉन्ग बेसिस का तो वो है ही है, हाँ हो गया। चल नेक्स्ट, वीक बेस वर्सेस स्ट्रॉन्ग, ये भी ठीक नहीं बना हुआ। चलिए नेक्स्ट, वीक बेस विद स्ट्रॉन्ग एसिड, ये भी छोड़ो, इसमें समझ ही नहीं आ रहा, आपको नहीं आएगा, मैं आपको खुद से बना के दिखा देता हूँ इधर। नेक्स्ट, सोशियोमेट्री तो क्लियर है, मैं आपको इसका कैलकुलेशन बता देता हूँ यहाँ से एक बार। आप ये देखिए स्टीप पोर्शन और ये टाइट्रेशन का वैसे बनेगा, समझ में आ रहा है? या कुछ और पूछना चाहते हो तो और देखो, ये है 4 pH, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, ठीक है। यहां से अब इस केस में यहां से शुरू होगी 3, 2, 1, 0, यहां से तो शुरू होगी pH, यहां से ये है स्टीप पोर्शन 7 के बाद ये वाला, ये मेरे को स्टीप पोर्शन मिल रहा है। यहाँ पे स्टीप पोर्शन बड़ा कम है, स्टीप पोर्शन इज वेरी लेस, बिकॉज 4 से 7 में कितना है, सारा चेंज आ रहा है, बढ़ता जा रहा है, बढ़ता जा रहा है, बढ़ेगा भी नेचुरली जब आप डालेंगे, बेस डालेंगे, तो ये ऑलमोस्ट ऐसे आ जाएगा आपको। यहां से यहां तक ये स्टीप पोर्शन बन गया। इसमें जो कलर चेंज इंडिकेटर चेंज करेगा वो मेरा सुटेबल इंडिकेटर। अगर मैं उल्टा करता हूं, वीक बेस वर्सेस स्ट्रॉन्ग एसिड, अब क्या होगा? अब स्टीप पोर्शन मुझे नीचे मिल रहा है, नीचे वाला मेरे कौन सा सुटेबल है? मिथाइल ऑयल। ओके, अब लास्ट में वीक एसिड वर्सेस वीक बेस में क्या करूं? वीक एसिड वर्सेस वीक बेस कौन सा है? वैसे सोच के देखो, कोई भी नहीं सुटेबल। वीक एसिड NH4OH, वीक वीक, अब क्या पोर्शन? ना इधर मिल रहा है ना इधर मिल रहा है। सो हार्डली एनी इंडिकेटर, बिकॉज स्टीप पोर्शन कम है, हार्डली एनी इंडिकेटर इज सुटेबल। So what we have to do is we have to increase the acidity or the basicity of the acid if we want to do the titration. ये नहीं है कि titration नहीं होगा। अब मेरे को बोरिक एसिड है, बोरिक एसिड इज अ वेरी वीक एसिड। बोरिक एसिड तो ऐसी चीज है कैरम बोर्ड पे लगा के खेलते हैं, हाथ में कुछ नहीं होता, इतना वीक एसिड है। अब बोरिक एसिड का मेरे को टाइट्रेट करनी है अगेंस्ट स्ट्रॉन्ग बेस, NaOH लेता हूँ, करनी मेरे को जरूर है, ये होगी नहीं वैसे बोरिक एसिड की, तो बोरिक एसिड को कुछ तो स्ट्रॉन्ग करना पड़ेगा। तो दूसरे मेथड है, उसके अंदर ग्लिसरॉल डाल देते हैं, हाइड्रोजन आयन जल्दी निकल जाते हैं कॉम्प्लेक्स बना के। सो यू कैन मैनिपुलेट द टाइट्रेशन इवन विद अ वीक एसिड, बट वीक एसिड वर्सेस वीक बेस में प्रॉब्लम आएगा बिकॉज नो सुटेबल इंडिकेटर इज अवेलेबल। मिक्स्ड इंडिकेटर्स हैं, चलाते हैं, बट You can always do potentiometric titration. उसमें indicator की जरूरत नहीं है. So there are several ways. Do you understand? Now the calculation part, you can do it. M1, V1, remember this thing for all reactions, complexometric or iodometric वगैरह हैं. और अभी how much time do I have? This is okay. Acid base, let's finish it off and then come to the redox titration. What is the principle in the redox titration? How do we use an indicator in the redox titrations? Oxidation reduction हो रहा है. Oxidation reduction, I have told you about, it is dependent on the E values, E0 values. Redox potential data pair. एक reaction होगा या नहीं होगा, we can determine on the basis of the E0 values. अब ये है MnO4 माइनस, मैंने आपको एक एग्जांपल बताया था Fe3+, ये रिडॉक्स समेशन रिएक्शन हाफ जो है ना ऐसे ही लिखते हैं, इनकी E0 वैल्यूज ऐसे ही लिखते हैं, +1.51 है, +0.75 है शायद, व्हाटएवर इट इज एग्जैक्टली नहीं. ये ऑक्सीडाइजिंग एजेंट इधर लिखते हैं, रिड्यूसिंग एजेंट इधर लिखते हैं, ऑक्सीडाइजिंग एजेंट इधर लिखते हैं, रिड्यूसिंग, ये नॉर्मल मेथड है लिखने का. E0, दे आर कॉल्ड रिडॉक्स कपल, हाफ सेल्स. E0 वैल्यूज आ गया. कौन सा किसके साथ रिएक्ट करेगा? एक इसका मेथड याद कर लो, कौन सा चीज किससे साथ रिएक्ट करेगी. इट इज डिटरमिन्ड बाय द E0 वैल्यू. E0 वैल्यू किससे डिटरमिन्ड होती है? E0 वैल्यू का सिग्निफिकेंस क्या है? Redox potential, is it connected to the, which reaction would take place? ये वाला रिएक्शन होगा इन दोनों में या इन दोनों में? ये दोनों ऑक्सीडाइजिंग एजेंट है, ये दोनों रिड्यूसिंग एजेंट है. रिएक्शन किसका किसके साथ होगा? इधर का इधर के साथ करूं कि इधर से करूं? किस डायरेक्शन में रिएक्शन जाएगा? ऐसे. ऊपर जो हायर वैल्यू है ना, पॉजिटिव हायर वैल्यू इंडिकेट्स डेल्टा जी is equal to minus NFE0. ठीक है, ये डेल्टा जी है. डेल्टा जी आप पढ़ा हुआ है ना कॉन्सेप्ट? नहीं. फ्री एनर्जी, डेल्टा जी नेगेटिव होती है तो स्पॉन्टेनियस होते हैं, डेल्टा जी है तो जीरो है तो इक्विलिब्रियम, डेल्टा जी पॉजिटिव है तो नहीं रिएक्शन होगा. तो डायरेक्शन ऑफ द रिएक्शन इससे होता है. खैर एनीवे, ये दोनों का रिएक्शन होगा और ये प्रोडक्ट बनेंगे. A stronger oxidizing agent will react. What is a stronger oxidizing agent? An oxidizing agent is a substance which takes up electrons. A reducing agent is a substance which gives electrons. What is the meaning of strong? Stronger reducing agent means it gives electron easily. A stronger oxidizing agent means it takes up electron easily. एक देगा एक लेगा, दोनों इकट्ठे ही होंगे, एक के बगैर दूसरा नहीं होगा. ठीक है. So strong will always react, strong oxidizing agent will react with strong reducing agent to give you a weaker oxidizing agent and a weaker reducing agent. weak नहीं कर पाएंगे आपस में. Direction of the reaction is determined. Molarity हो गई, ये हो गया. Everything is dependent. If you want to do a redox titration, everything is dependent on now E0 value. Solution की जो E value है क्या है, वो नॉन्स्ट इक्वेशन से डिसाइड की है. आपने पढ़ी होगी इलेक्ट्रोकेमिकल सेल्स, भी पढ़े थे शायद, है ना? पढ़े थे ना? अभी मैम बता रही थी कोई, E is equal to E0 plus RT NF by log ln ऑक्सीडाइजिंग रिड्यूसिंग एजेंट. नहीं पढ़ा? नॉन्स्ट इक्वेशन. एक्चुअल पोटेंशियल जो होता है ई सॉल्यूशन का, वो नॉन्स्ट इक्वेशन से डिसाइड होता है. अब मैं आपको एक एग्जांपल देके ना इसकी भी टाइट्रेशन बना देता हूँ, तो आपको थोड़ा अच्छे से समझ में आ जाएगा. बाकी न्यूमेरिकल एक दो रह जाएंगे पढ़ने हैं. तो ये ना, अब एक रिएक्शन है, डिसीजन कहाँ से लेना है? यहाँ पे एसिड बेस में क्या था? चेंज इन द पीएच. यहाँ पे क्या है, चेंज इन द ई वैल्यूज, डिसीजंस यहाँ से होंगे सारे। अब ये है एक रिएक्शन है, लिख लो, इसमें थोड़ा समझने के लिए है, वैसे और कुछ नहीं है। सीरियम 4+ ऑक्सीडाइजिंग एजेंट है, पैरासाइंस रिड्यूसिंग एजेंट है, सीरियम ऑक्सीडाइजिंग एजेंट, reducing agent. It gets converted into cerium 3+ and stoichiometry बिल्कुल ठीक है, एक एक का फर्क है, कुछ ज्यादा बॉदरेशन नहीं है। at 25 डिग्री सेल्सियस, ठीक है। अब रिएक्शन एक कर रहे हैं, एक टाइट्रेशन कर रहे हैं हम लोग, एंड वी सी हाउ द ई वैल्यू चेंजेस, चेंज होगी उसके हिसाब से फिर इंडिकेटर डिसाइड करेंगे। अब मेरे पास है ऑक्सीडाइजिंग एजेंट, ये मैंने ब्यूरेट है, सीरियम 4+ आयन का सॉल्यूशन है, ये ऑक्सीडाइजिंग एजेंट है, ये पिपेट से 10 ml लिया, फेरस आयन का सॉल्यूशन, ठीक हो गया, ये सॉल्यूशन है। ठीक है, Fe3+ और Fe2+ का जो हाफ सेल का है, E0 वैल्यू है आपकी 0.75 वोल्ट, ठीक है। इसमें सॉल्यूशन में व्हाट वुड बी दी ई वैल्यू, जो E0 वैल्यू है 25 डिग्री पे है, मोलर कॉन्सेंट्रेशन है तो इतनी आएगी, सेम वैल्यू इसकी जो सॉल्यूशन की होगी। हाँ, उसके बाद इफ आई ऐड 10 ml ऑफ सीरिकाइंस, ये 100 ml है, बाकी कितना बचा, E1 कितना हो गया, E1 जो एक्चुअल वैल्यू है 0.75 प्लस 0.059 log ऑफ 10/90, 100 ml ये है पैरासाइन सॉल्यूशन, ठीक है, समझ में आ गया। ये नॉन स्टिक इक्वेशन कहलाती है। हाँ, ये है एक्चुअल में ना ln का 2.2303 लॉग बनाने के लिए ना, नेचुरल लॉग इज इक्वल टू 2.303 लॉग वो है, और फैराडेज कांस्टेंट है, NF है, N इज द नंबर ऑफ इलेक्ट्रॉन्स लॉस्ट और गेन्ड, ये N है, NF है, N is the number of electrons lost or gained, F is the Faraday's constant, ये टोटल मिला के 0.059, और इसको एक नंबर ऑफ इलेक्ट्रॉन है तो एक से किया लॉग, ये है कंसंट्रेशन। अब मेरे पास ये है फेरिक आयन कितना बना, और 10 ml मैंने डाला सीरिक आयन। अब सोच के देखो, मैंने ऑक्सीडाइजिंग एजेंट 10 ml डाला, ठीक है, फेरसाइन कितना बच गया मेरे पास 90, और फेरिक आयन कितना बन गया 10, ठीक है, इनकी रेशो 10/90 आ गई, ठीक हो गया, समझ में आ रहा है। देखो 100 ml मैंने फेरसाइन का सॉल्यूशन लिया, अब उसमें से पहली बार में मैंने 10 ml डाल दिया सिलिकॉन, ऑक्सीडाइजिंग एजेंट है, और 10 ml विल ऑक्सीडाइज 10 ml ऑफ फेरस आयंस टू फेरिक आयंस। तो बना कितना? 10 फेरिक आयन बन गया। ठीक है, ये हो गया फेरिक का, ये फेरस। ठीक है, इसकी वैल्यू ये हो गई, बचा कितना रह गया? इतना। तो E की वैल्यू जो एक्चुअल पोटेंशियल है कितना आ गया? 0.75 प्लस ये 0.5, इसकी वैल्यू आ गई 0.75 माइनस 0.056 इज इक्वल टू जो भी आ गई। ठीक है, 0.69 पोटेंशियल। 50 ml डाल दिया, 50-50 हो गया, 1 log 1 हो गया, सब कुछ 0 हो गया। तो 50 ml डालने पे क्या हुआ? इट विल ऑक्सीडाइज 50 ml ऑफ फेरसाइन ऑफ द सेम नॉर्मेलिटी, एंड बाकी बचा हुआ फेरिक आयन हो गया, 50-50 हो गया, तो 1 हो गया log 1। तो ये वैल्यू मेरी आ गई एग्जैक्टली इतनी, ये खत्म हो गया। समझ में आ गया? हाफ वे टाइट्रेशन में जो इसका पोटेंशियल था वो आ गया मेरे पास, E0 वैल्यू। Actual potential changes with temperature, actual changes with this ratio of the concentration of oxidizing and reducing agents, ये सारी चीजें चेंज होती हैं। पोटेंशियल यहाँ का अलग है, E0 फिक्स्ड है, वो चेंज नहीं होता। अब 90 डाल दिया, 10 बच गया, 10 over 90 over 10 हो गया ना। ठीक है, तो log 9 का log 1 आ गया, वो माइनस कर दिया, वो कितना बने? वो प्लस हो गया ना, तो कितना बन गया? 90 ml के साथ है, with 90 ml E is equal to 0.75 plus 0.0591 log of 90 over 10 is equal to 0.81 volt। अब पोटेंशियल बढ़ने लगा। सिचुएशन सिमिलैरिटी दिखा रहा हूं एसिड बेस की। 99 पे क्या होगा? लॉग, ठीक है, यही चीज विद 99 ml, ये वैल्यू आ जाएगी 99 की 0.87। ठीक है, 100 ml पे 99.9 पे करो। चलो, अब वही है ना, हमें तो एंड पॉइंट, इक्वलेंस पॉइंट और एंड पॉइंट में वो देखना है ना क्या होता है, क्या पोटेंशियल। तो क्या हो जाएगा? लॉग ऑफ, बाकी वही चीज है। ठीक है, ये अपने आप लिख लेना बेटे, मैं ज्यादा ये सारी चीजें वही हैं। 0.1 हो गया। अब ये वैल्यू कितनी आ गई? 93। अब इतना वोल्ट बढ़ गया, अच्छा बढ़ रहा है। 0.9 से देखो, 9 ml से 0.06 बढ़ा है, और 0.9 ml से 0.06 बढ़ा है, बड़ा उतना ही है। ठीक है ना, समझ रहे हो? 100 पे क्या होगा? 100 पे एग्जैक्ट 100 पे सब बराबर हो गया। अब 100 पे जाके क्या आ जाएगा? इन दोनों के जो पोटेंशियल है, सीरिक और इसका, इसकी वैल्यू कितनी है 100 पे? सीरिक वाले की 1.45 है। इन दोनों का E1 प्लस E2 डिवाइडेड बाई 2, ये कितना आ जाता है? 1.10। 100 पे E1 plus E2 divided by 2, 1.10 volt. Jump 100.1 पे फिर कितना आ जाएगा? वो सीरीक वाला शुरू हो जाएगा. Now iron खत्म हो गया. No more iron is there. Fe2 plus finished. Now extra steric 4 is there. This potential comes, ये 1.45 इसके आसपास आ जाएगा. So within 0.1 ml this way and that way, the potential jumps, and the type of the graph you will get is the same. Potential का graph करोगे फिर वही मिलेगा. Steep portion. E0 values का समझ में आ गया? Are you following my point? Time is over. Okay. So this is it. I'm going to wind it up now within 1 minute or so. This part is okay. This T portion would help you to decide that this is the portion, this is your titration for redox reactions. Similarly, you will have for complexometric titration where the concentration of the metal ion forms complexes. So the concentration changes against T portion. So this T portion has a definite meaning for us, and it is definite value. And the calculation parts, I'm sorry I couldn't do it because it's laxity of time. I got late and delayed by some of the problems because I am not sure about it, what the exact location of this place. So anyway, thank you very much indeed. So nice of you people to have heard me in patience and without interfering. And I expected a lot of questions, but you never asked many. You want to ask any questions? Please come outside, and then if you have any more questions, we can discuss it outside. Thank you.